So we'll create a prop products equals curly brackets, and we'll give it the products. So as you can see, this makes the code much cleaner when we separate it into smaller components. The last step is at the top, we can remove this format money function since we're not using it anymore. Let's save and let's open the website and make sure everything still works. So that looks good. Next, we're going to do the checkout page. So we'll go back to our code and we're going to open the checkout page and we're going to scroll to the top. And I'll leave separating the checkout header as an exercise. But we're going to scroll down here and we can move the order summary section into its own component. So inside the pages folder, I'm going to click it and create a new folder called checkout. Now, you might have already done this if you did the exercises from the previous lesson. But we're going to use this folder checkout, and I'm going to move the checkout page inside here and update the imports and also move the CSS files. And I'll make sure that the imports look good. So in here at the top, make sure there's 2 ... slashes in front, and inside app.jsx, make sure that there is a checkout folder in front of this component. So I'll go back to the checkout page and I'll create a new file. Let's call it the order summary.jsx. And we're going to create export function order summary brackets and curly brackets. And we're going to return brackets the HTML for the order summary. Inside the checkout page, we're going to scroll down and find the order summary. We can collapse it and select this code and copy. Inside the order summary, we'll paste and press Ctrl or Command-Shift-P and format document. And we'll scroll to the top. And we're going to need the delivery options and the cart inside here. So we're going to get this from the props using curly brackets, the cart, comma, and the delivery options. And we also need day.js and the format money function. So at the top, we'll also import day.js from day.js and import curly brackets format money from the string, and we'll find the utils file, which is /utils/money. And all the errors should now be gone. We'll save, and inside checkout page, we can remove this code, and we can use our new component, less than order summary / greater than, and we need to give it the cart equals curly brackets and save the cart. And we need to give it the delivery options equals curly brackets and give it the delivery options. And we need to import this at the top. So we'll scroll up, and here we can import curly brackets the order summary from a string ./order summary. And we don't need day.js anymore. So let's save and check the website, and everything still works. We'll go back and scroll down. And next, we can also move the payment summary into its own component. Feel free to pause the video if you want to try it yourself first. So inside the checkout folder, we'll click here and create a new file, payment summary.jsx, and we'll create the component export function payment summary brackets and curly brackets, and we'll return the HTML. Inside the checkout page, we're going to collapse this element and select the HTML and copy. Inside the payment summary, we're going to paste, Control or Command-Shift-P, format document, and we're going to scroll back up, and we're going to get the payment summary from the props. So curly brackets, payment summary, and we need the format money function. So up here, import curly brackets, format money from a string, dot dot slash, dot dot slash, utils slash money, and save. In the checkout page, we can remove this code and replace it with less than payment summary slash greater than. And we need to give this the payment summary equals curly brackets and save the payment summary. And as you can see, our code is much cleaner now because we separated it into smaller components. So now we need to import this. So we're going to scroll to the top, and here we'll import curly brackets, the payment summary from a string dot slash payment summary. And we don't need format money anymore. And save. Let's go back to the website, and everything is still working. We'll go back to our code, and we're going to go inside the order summary component. So in here, the code is still a little bit too complicated. So what we can do is we can find this element with the class delivery options, and we can separate this into its own component as well. Feel free to pause the video if you want to try this yourself first. So I'm going to go to the checkout folder and create a new file and name it delivery options.jsx. And we'll create a component export function delivery options brackets and curly brackets and return some HTML and back to the order summary. And here we can collapse this element and select it and copy inside delivery options. Inside here, we can paste Control or Command Shift P and format document. And we'll scroll to the top. Here, we need to get the delivery options using the props, so curly brackets, delivery options. And we're going to import format money. So up here, we're going to import curly brackets, format money from a string, dot dot slash, utils slash money. And we also need day.js. So up here, we'll import day.js from a string, day.js. And I think we also need another thing here, which is the cart item. So we're going to get this from the props as well. So up here, we're also going to get the cart item and save. And now in the order summary, we can replace all this code with our component less than delivery options slash greater than. And we're going to give it the cart item equals curly brackets, save the cart item, and give it the delivery options equals curly brackets, save the delivery options. And we also need to import this. So at the top, we can import curly brackets, the delivery options from a string dot slash delivery options and save. And let's check our website and make sure it still works. So that looks good to me. So if we go back to our code, you can see that our code is cleaner now after we separate this into another component. And remember, it's up to us how we want to separate our components. We can actually keep separating this into smaller components if we want. For example, we can also have a cart item details component or a delivery date component, but I'll leave these as exercises. I'm also going to leave the orders page as an exercise, but we can just get started on it. So here, inside the pages folder, we're going to create a new folder for the orders page. So orders. And we're going to move this component inside here and update the imports. And we're going to move this inside here as well. and just make sure the imports look okay. So in here, we'll scroll up, make sure that these two have two ... slashes in front. That looks good. And in app.jsx, make sure that the orders page is now inside an orders folder. So we'll save this and open the website. And we're going to click here to go to home and click here to go to orders. And the orders page should still be working. So I'll leave separating this as an exercise. We'll go back to our code and we'll save this into Git. Inside the Git section, we'll create the message separate into smaller components and commit. Next, we're going to go back to our files and we're going to go to our home page. And we're going to review async await. Async await is a feature of JavaScript, and it lets us write asynchronous code like normal code. Right now, we're using promises, which means we need to use .then to wait for this code to finish, and then run this function. With async await, we can actually write this like normal code. To do that, in front of Axios, we can type await and space. So this is going to wait for this code to finish, and then it's going to move on to the next line. And now, because we're waiting for this code to finish, we can actually save this result in a variable. So at the front, we can save it in const response equals await this code. And now we don't need to use .then anymore. And we can remove it. However, in order to use await, we need to be inside an async function. So in front of this function, we need to add async and space. As you can see, async await lets us write asynchronous code like normal code, or code that runs line by line. And async await makes the code easier to understand. So in React, it's recommended to use async await instead of promises when we can. However, in React, there is a small problem with using async await and useEffect. As a review, when we put async in front of a function, this function will now return a promise. That's because this function has some asynchronous code inside, or code that takes some time to finish. So that means that this entire function is going to take some time to finish. That's why it has to return a promise. Now the problem is the inner function in useEffect should not return a promise. It should only return nothing or a cleanup function like this. A cleanup function is useful if we want to do some cleanup when this component is removed. So because this inner function is now returning a promise, it's sort of breaking the rules of useEffect. To solve this, we usually create a new function inside useEffect, like const get home data equals, and create a new function, brackets, arrow, and curly brackets. And we're going to make this function async. And we'll leave this as an ordinary function. And now we're going to move our code inside here. So we'll cut it and paste it. And now because we're inside an async function, we can now use await. And it will also not mess up useEffect. At the end, we just need to run this function using get home data and brackets. So this gets the same data as before, but it uses async await. So remember, when using async await inside useEffect, we need to create a new function and then run the function. Otherwise, it will break the rules of useEffect. So let's save and check the home page and go to the home page, and everything still works. So let's go back and we'll use async await in the app component where we get the cart. So here, feel free to pause if you want to try it yourself first. We'll create a new function using const. Let's call it fetch app data equals a function brackets, arrow, and curly brackets. And we'll move this code into the function. So we'll cut and paste. And we'll select this and press tab. In front of the function, we'll use async. And now we can use await inside. So in front of Axios, we'll type await to wait for this to finish. And then we're going to save the result in a variable. Const response equals this result. And now we can remove .then and these brackets. And the code is much cleaner. Finally, we're going to run this function, fetch app data and brackets, and save. And let's do the same thing in the checkout page. So we'll go to the checkout page here. Feel free to pause if you want to try it yourself. Const fetch checkout data equals brackets, arrow, and curly brackets. And we'll move this code inside, cut, and in here, paste, and select these lines and press tab. And we're going to turn this into an async function. So we can use await inside. So in front of this request, we're going to await, and we're going to save it in a variable let response equals. So we're going to use let because we have two requests here, and we might want to reuse this variable. And I'll add a new line to make it a little easier to read. And now we can remove .then. And then down here, we'll also use await to wait for this to finish. And we're going to save the result inside response equals. And now we can remove .then. And the last step is to run this function. So fetch checkout data and brackets and save. We'll open the website, make sure the home page is working, and then go to the checkout page and make sure this is still working. So that looks good to me. We'll go back to our code, and that's async await. It lets us write asynchronous code like normal code. I'll leave converting the orders page to async await as an exercise. So now we can save this into Git. We'll give it the message convert home and checkout to async await and commit. In the next lesson, we're going to learn data mutation, which means instead of just getting data from the backend, we'll update data in the backend, and we'll be able to add products to our cart and create orders. And that's the end of this lesson. In this lesson, we reviewed backend, which manages the data for a website. We set up a backend for our project. We learned how to fetch data or get data from the backend. We learned Axios, which is an easier way to make requests to the backend. We learned how to generate the HTML using the data from the backend. We separated our pages into smaller components, and we learned async await, which lets us write asynchronous code like normal code. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn data mutation, and we're going to make the website interactive. Data mutation means we update data in the backend. If we open the website and I'll close some of these other tabs. If we go to the home page, notice that right now we can only view the data. If we try to update this data, like we try to add to cart, it doesn't do anything. So we're going to make this add to cart button work. We'll go to our code and we're going to find the add to cart button. So I'll open my files and I'm going to go to the home page and we're going to open the products grid. And we're going to scroll down in this file to this add to cart button. The first step is to make this button interactive. So at the end, we're going to add an onClick attribute equals curly brackets and give this a function, brackets, arrow, and curly brackets. As a review, onClick is called an event handler. When we click this button, it will run this function. Now, inside here, we're going to add the product to the cart. So we could try to update the cart here in React, but then we have to figure out where to save the cart. Instead, in the real world, we use the backend to update the cart and to save the cart. The advantage of using the backend is it will simplify our React code, and we can share the data in the backend. So if we access this website from another computer, we can access the updated cart using the backend. So here, to use the backend to add a product to the cart, we're just going to make another request to the backend. We're going to go to the top, and at the top, we're going to import Axios so that we can make another request. And we'll scroll back down. And when we click this button, we're going to make a request to the backend using Axios. And this time we're going to use .post and brackets. So previously we used Axios.get to get data from the backend. Post is a different type of request. .post is used to create data in the backend. In this case, we are adding a product to the backend. So we're creating a new cart item. That's why we use .post. Inside here, we're going to give it a URL path /API/cart-items. So notice this is the same URL path that we used to get the cart, but when we use post, the backend will behave differently. This will create a cart item instead of getting the cart items. Next, we need to tell the backend which product to add to the cart. To do that, we can give Axios.post another value, which is an object. When we use post, we can also send information to the backend using an object. And this is called the request body. Now, the backend needs to know two things in order to add a product to the cart. First, it needs to know the product ID that we want to add. In this case, this button is for, if we scroll up, the button is for this product right here. So at the bottom, we're going to tell the backend we want to add this product.id to the cart. And we also need another information, which is the quantity that we want to add. For now, let's just use the quantity 1. So this code will send a request to the backend, telling it to add this product to the cart with a quantity of 1. So now let's save this file, and then we'll go to the website, and we're going to go to this t-shirt product, and we're going to click Add to Cart. And then we're going to refresh the page. And now, if we look at the cart here, we have one more product. The quantity is 4. If we open the cart and we scroll to the bottom, notice that it added the t-shirt to the cart. So that's how we do data mutation or update data in the backend. We just send a request to the backend, and the backend takes care of updating and saving the data. So in the real world, we use the backend to manage and update the data. Next, notice that when we added this product to the cart, we had to refresh the page to see the new cart. it would be better if we could just reload the cart and update the page without needing to refresh. We'll go to our code, and at the bottom, we're going to go to app.jsx. So here, this code reloads the cart from the backend, and it updates the state. After it updates the state, React will update the page. So when we add a product to the cart, we just need to rerun this code, and it will update the page. And then we don't have to refresh the page every time. We're going to select this entire function, and we'll cut, and outside the use effect, we're going to paste it. And now that it's outside the use effect, we can share this function with our components. Now, let's actually rename this function to something more accurate, like load cart. And in here, load cart. And now we can share this with our components using a prop. So we're going to scroll down here, and in the home page, we're going to give it the prop load cart equals curly brackets, and we'll give it the function load cart and save. And now if we go to the home page, at the top, we'll get load cart out of the props and then give it to the products grid component. So remember, this component contains the add to cart button. So in here, we'll give it another prop, load cart equals curly brackets, and give it the load cart function and save. And now inside the products grid, at the top, we're going to get load cart out of the props. And then if we scroll back down, after we update the cart, we're going to call the function load cart. So this means we will update the cart in the backend, and then we'll get the new cart and update the page without needing to refresh. One other thing we have to do here is, remember, Axios.post contacts the backend. So this is asynchronous code. It does not finish right away. That means we need to wait for this code to finish before going on to the next line. To wait for this to finish, at the front of this code, we can type await and space. And remember, in order to use await, we need to be inside an async function. So we'll add async. And also, this code is not inside a use effect. So we can just use async directly here, like this. After that, load cart is also asynchronous. So it's a good idea to await this code as well to be consistent. So now let's save, and we'll check the website. And first we'll go back to the home page. And this time, let's click add to cart on this toaster. So we'll click add to cart. And now notice that the quantity here updated to 5 without needing to refresh. If we go to the cart and scroll down, it also updated the cart on the page without needing to refresh. We'll go back to the home page, and we're going to make these quantity selectors work. So this lets us add more than one product to the cart at a time. We're going to go to our code, and first we need to get the quantity in the quantity selector. To do that, we're going to use a controlled input. We learned controlled inputs when creating the text box in the chatbot project. So as a review, we'll scroll up, and we're going to create a state to save the quantity. At the top, we're going to import curly brackets use state from React. And in this component, we're going to create a state, const square bracket equals use state and brackets. And we're going to name this state the quantity, comma, and the updater function set quantity. And we'll set the starting value of the quantity to 1. Then we're going to scroll down, and we're going to find this select element. So this element represents the selector on the page. And we're going to give this two props. The first prop is the value equals curly brackets, and the value is the quantity. The second prop is on change equals curly brackets, and we're going to give this a function. So brackets, arrow, and curly brackets. And whenever we use an event handler like onClick or onChange, this function gets a parameter called event. So event contains details about the event. In this case, the event will contain the quantity that we selected, which is one of these values. To get the quantity that we selected, we can use event.target.value. And let's save the quantity we selected in a variable. At the front, we'll create const quantity selected equals this value. Now, one thing to be careful of is this value is going to be one of these values here. And these are going to be a string. So we need to convert it into a number. To do that, around this value, we're going to use the code capital N number, open bracket, and close bracket. So this will convert the string here into a number. So now that we have the quantity that we selected, let's save it into the state using set quantity brackets quantity selected. So this is called a controlled input when we have a value and an onChange property. When we change the selector, it's going to set the quantity in the state, and then the new state is going to be set as the value, and then it updates the page. So we're basically putting React in the middle of this process so that we have access to the quantity that we selected. And that's a review of how controlled inputs work. And let's also console.log the quantity selected to see if it works. So we'll save and we'll go to the website and we're going to open the console with right-click, inspect, and the console. And now on the website, we're going to click the quantity selector here and we'll select 3. And now inside the console, it displays the quantity that we selected. However, there is a problem here. Notice on this website, when we change one quantity selector, it changes all of them. So if I change this one here to 5, it changes all the quantities. So let's fix this. We'll go back to the code. And if we scroll to the top, this is happening because the state here is outside of this loop. So that means the state is shared across all the products. That's why when we change one selector, it changes all of them. To solve this problem, we need to move this state inside this loop so that each product has its own quantity. So we're going to select this code and cut. And inside this loop, we're going to paste. However, this code actually breaks the rules of React hooks. We can only put hooks at the top level of a component. We should not put hooks inside a loop like this. To fix this problem, we can separate each product into its own component. So inside the home folder, we're going to create a new file and we'll name it product.jsx. And we'll create a component for each product, which is export function product, brackets and curly brackets, and we're going to return the HTML for each product. Inside the products grid, we're going to collapse this code, and this is the code for each product. So we'll select it and copy, and inside the product component, we're going to paste. And then Control or Command Shift P, format document. We'll scroll up and we'll go back to the products grid. And we also need to copy over the state. So we're going to select this, copy, and inside product at the top, we're going to paste. And we'll fix these errors. So first we need to import use state. At the top, we'll import curly brackets use state from React. And the product, we'll get it from the props using curly brackets product. Scroll down. We'll need the format money function, as well as Axios and load cart. So first, we'll import curly brackets format money from a string, and we'll find //utils/money. At the top, we're going to import Axios from Axios, and we'll get the load cart function from the props. So comma load cart and save. So now each product has a separate state. It has its own quantity. And this is no longer breaking the rules of hooks because this state is at the top level of this component. We'll go back to the products grid. And here we can remove this HTML and just use our component less than product / greater than. And we need to give it the product equals product, and also the load cart function equals load cart. And we can remove this state. And remember, when we loop through an array, we need to give it a key prop. So at the front here, we'll set a key equals curly brackets, and we'll set it to the product.id. And finally, we need to import this component. So we'll scroll up, and at the top, we'll import curly brackets, the product component from a string, and it's right beside this file. So we'll do ./product. And we can remove these because they're no longer being used. And save. And since we have the key in this loop here, we can also go into the product and remove the key in here. And save. Now let's open the website. And if we change one of these selectors, notice that each product can now have its own quantity. Now that we have this quantity, when we add a product to the cart, let's use this quantity. We'll go to our code, and we're going to go inside each product, and we're going to scroll down to the Add to Cart button here. And instead of adding a quantity of 1 every time, we're going to add the quantity that is saved in the state above. So now let's save, and we'll try out this code. We'll open the website, and let's go to this plate product, and we're going to select a quantity of 3 this time. And we'll click Add to Cart. And notice that the cart updated, and it now has a quantity of 8, which is 3 more than before. If we open the cart and we scroll to the bottom, we now have 3 of these plates in the cart. So now the quantity selector is working. Let's go back to the home page. And this time, let's try adding a product that already exists in the cart. So for the plate product, we're going to select the quantity of 3 again, and we're going to click Add to Cart. Notice the cart quantity increased by 3, and if we open the cart and scroll down, instead of adding a new plate product, it just increased the quantity by 3 for a total of 6. So if the product already exists in the cart, the backend handles this situation for us and just increases the quantity. Remember, the purpose of the backend is to manage the data. By letting the backend manage and update the data, we can simplify our React code. Let's go back to our code, and we're going to do some cleanup in this component. First, instead of doing quantity : quantity, we can use the shorthand property syntax and just use the quantity. It does the same thing as before. Next, instead of putting our event handlers directly in the HTML like this, we usually save this in a separate function. So let's select all this code and copy, and we're going to scroll up, and at the top, we're going to create a function const add to cart equals, and we'll paste that code. So we usually save the function separately like this, and then we can scroll down. We can remove this code and just use the function name add to cart. And this makes the code easier to read. Next, we'll scroll up to the quantity selector. We can remove the console.log, and we'll move this into a separate function as well. We'll select this code and copy, and we'll scroll up. And here, we're going to create another function, const select quantity, and make it equal, and we'll paste that code. And we'll use this function below. So down here, instead of putting this function directly in the HTML, we'll use the function name select quantity and save. And that's it. We created the add to cart feature. In the final project, there's a small message that pops up when we click add to cart, but I'll leave this as an exercise. Now let's save this into Git. We'll open the Git section, and let's use the message create add to cart feature and commit. Before we continue, I want to go back to the code that we wrote. So we're going to scroll up in this component, and I want to explain Axios.post a little more. As a review, when we send a request to the backend, we can set a URL path. Based on the URL path, the backend can do different things. For example, if we use /API/products, the backend gives us the products. If we use /API/cart items, the backend gives us the cart. In addition to the URL path, every request also has a type. In the previous lesson, when we did Axios.get/API/cart items, this actually sends the type get and the URL path /API/cart items to the backend. So it sends two pieces of information to the backend, the type and the URL path. When we did Axios.post/API/cart items, this sends the type post and the URL path /API/cart items to the backend. Now, when the backend receives our request, it looks at both the type and the URL path to decide what to do. For example, if the backend receives get and /API/cart items, it will get the cart items and return it. If the backend receives post and /API/cart items, it will create a new cart item. So both the type and the URL path together determine what the backend does. In the description, I have a documentation page for my backend, and it lists all the different requests that my backend supports. Notice that each request has a type and a URL path. By the way, the type is also called a HTTP method. When working with a backend, there are 4 common types of requests that we use: get, post, put, and delete. Get means we want to get some data. Post means we want to create some data. Put means we want to update some data. And delete means we want to delete some data. So Axios has a method for each type. Axios.get sets the type of request to get. Axios.post sets the type to post. Axios.put sets the type to put. And Axios.delete sets the type to delete. And then between the brackets, we put the URL path. So in our code, this sends a request to the backend with the type post and the URL path /API/cart items. So the most important thing to remember here is that each request has a type and a URL path, and both of these determine what the backend will do. In the rest of this lesson, we'll get more practice sending different types of requests to the backend. Next, let's go back to the website. And inside the checkout page, for each product, we have these delivery options. So we're going to add the ability to update the delivery option. Because we're updating something in the cart, we're going to practice using a put request. First, let's find the code for these delivery options. We'll go back to our code and open our files. And we're going to find the pages and checkout folder, and we're going to open deliveryoptions.jsx. And we'll scroll down. And here, each of these represents one delivery option on the page. So we're going to put an onClick property on this element. Now, usually we put the onClick on the input, but in this case, this will make only the radio selector clickable. Instead, we want the entire delivery option, including the text, to be clickable. So that's why we're going to put the onClick on the outside component. So we're going to add the onClick attribute equals curly brackets, and let's create a function for this. Above this, we'll create a function with const, and let's name it update delivery option equals, and let's make it an async function, brackets, arrow, and curly brackets, because we know we're going to make a request to the backend to update the delivery option. Also, we create the function here inside of this loop because we need access to each delivery option. So next, to update the delivery option for a product, we're going to make a request to the backend. We're going to scroll to the top, and at the top, we'll import Axios from Axios. And we'll scroll back down. And inside here, according to my documentation, my backend supports the request put/API/cart items. This lets us update the cart. For example, we can update the delivery option for a product. So we're going to do Axios.put brackets. This sends a request with the type put to the backend. And we'll set the URL path to /API/cart-items. And we'll add another slash, and we're going to insert the product ID that we want to update here at the end of the URL path. So in my documentation, :product ID is known as a URL parameter. This means my backend wants the product ID we want to update inside the URL. This is just a naming convention that is popular with backends. When we update something, we usually put the ID of what we want to update inside the URL. So here, first we're going to change this to a template string using backticks. And then at the end, we'll insert $curly brackets, and we're going to insert the product ID that we want to update. So the product ID is saved inside the cart item. So inside here, we're going to insert the cart item dot product ID. Next, we need to tell the backend which delivery option we want to update to. To do that, we're going to give the backend some data. At the end of this, we'll add a comma and an object. And in my documentation, this section tells us what data we can send to the backend. Here, we can send the delivery option ID that we want to update to. So we're going to give the backend the delivery option ID that we want to update to. So if we scroll up here, we want to update to this delivery option. So we'll tell the backend to update to the delivery option cart.id. And after we update the delivery option, we're going to reload the cart and update the page. So in front of this, let's wait for this to finish using await. And remember, we created a function for reloading the cart called loadCart. So inside app.jsx, we're going to share loadCart with the checkout page. So down here, we'll add a prop, loadCart equals curly brackets, loadCart, and save. And then inside the checkout page, at the top, we're going to get load cart. And now we need to share this with the delivery options. Now the delivery options are actually inside the order summary. So we're going to share it with the order summary first. We'll scroll down to the order summary. And here, we're going to give it the load cart equals curly brackets, load cart, and save. Inside the order summary, at the top, we're going to get from the props load cart, and then we're going to share it with the delivery options. So we'll scroll down to these delivery options, and we'll give it the prop load cart equals curly brackets, load cart, and save. And finally, in the delivery options, we can get load cart from the props. So comma load cart, and scroll down. After we update the delivery option, we're going to await load cart and brackets so that we reload the cart and update the page, and we don't have to refresh to see the updates. Finally, we're going to take this function and put it in this onClick. So update delivery option and save. Now let's go to the website and we'll try changing a delivery option. And now you can see that it updates when we change the delivery option. Now, one last thing here is if we open the console, we're going to get this warning message saying we provided a checked property without an onChange handler. So let's fix this warning. We're going to go back to the code. And the warning means that for an input element, if we have a checked prop, we should also have an onChange prop. OnChange lets us change the value of this input. However, in our situation, we already use this onClick up here to change the value of the input. So we don't really need an onChange property. So in here, to get rid of that warning, we can just add an onChange property equals curly brackets and give it an empty function. And this will just make the warning go away. We'll save and go back to our website. And let's refresh. And now if we change the delivery option and check the console, we no longer get that warning. Next, we have another problem on this page, which is when we update the delivery option, the payment summary here is not updating to show the new delivery price. To fix this, after we update a delivery option, we also want to reload the payment summary. So let's find the code for reloading the payment summary. We'll go to our code, and we're going to open the checkout page. And we're going to scroll up, and inside this use effect, we have this code here that reloads the payment summary. So we want to rerun this code after updating the delivery option. Now, we could separate this into a function and then share it like we did with loadCart. However, we have an easier option here. Remember that in useEffect, at the end, we have this dependency array. So this array determines when useEffect runs. Right now, it's empty, which means useEffect will only run once. However, we can put values inside this array. And whenever a value changes, it will rerun the useEffect. In our situation, we can put the value cart inside this dependency array. And now, whenever the cart changes, it will rerun the useEffect and update the payment summary. And that makes sense. Every time the cart changes, we do want to update the payment summary in case the cost of the order changes. So in React, there are often multiple solutions to do something, and we should try to pick the cleanest solution. Also note that this will cause the delivery options to be reloaded, which is not really necessary. So we could separate reloading the payment summary into another useEffect, but I'll leave this as an exercise. So now let's save, and we'll go to our website. And now when we update the delivery option, notice that the payment summary also updates to show the new delivery price. And now this feature is working. So now let's save this into Git. We'll go back to our code and open the Git section. And here we'll use the message create update delivery option feature and commit. Next, we're going to go to our website and we're going to work on deleting an item from the cart. So we're going to practice making a delete request to the backend. First, we're going to find the code for this delete link. We'll go to our code, and in our files, we're going to find the order summary component. And we're going to scroll down in this component and find the delete link. If you did the exercises, this might be inside a cart item details component. Now for this delete link, we're going to add an onClick attribute equals curly brackets, and we'll give this a function to run. Let's call it delete cart item. And let's create this function above. So I'm going to scroll up, and I'm going to create the function inside this loop because I need access to this cart item to delete. So in here, we'll create the function const delete cart item equals a function. And let's make this an async function because we know we're going to make a request to the backend. And first, let's import Axios. So we'll scroll up, and at the top, we'll import Axios from a string Axios. And then inside this function, my backend can receive a request called delete/API/cart items. And this will delete a product from the cart. So we'll do Axios.delete and brackets. This sends a request with the type delete to the backend. For the URL path, we're going to use a template string, and we'll do /API/cart-items/ and we're going to insert the product ID in the URL again. This is just a naming convention that my backend uses. So we're going to insert the ID of what we want to delete. In this case, we need to give the backend the product ID we want to delete. So the product ID is saved inside the cart item. So we're going to give the backend the cart item.product ID. And that's it. When my backend receives a request with the type delete and this URL path, it's going to delete this product from the cart. So after deleting the product, let's reload the cart. First, at the front of this, we'll type await to wait for this code to finish. And then we're going to await load the cart and brackets. So I have load cart already in the order summary. If you did the exercises from the previous lesson, you may need to pass this function into your component using a prop. So now let's go down, and that's all we need to delete a product from the cart and then reload and update the page. Let's save. We'll go to the website, and we're going to delete this first product. And notice it updates the cart, and it also updates the payment summary. If we delete another product, you'll notice it updates the cart and updates the payment summary. So that's how we make the delete link work. I'll leave updating the quantity in the cart as an exercise. So now let's save this into Git. We'll open the Git section, and then here we'll use the message create delete cart item feature and commit. Let's go back to the website, and in the checkout page, we're going to add the ability to create an order. So first, let's find the code for this place order button. We'll go back to our code, and in our files, we're going to open the payment summary component, and we're going to scroll down to the bottom to this place order button. And to this button, we're going to add a prop on click equals curly brackets, and we'll give it a function. Let's call it create order. And now let's scroll up and create this function. So up here, we're going to create const, and we'll name it create order equals an async function, brackets, arrow, and curly brackets. Again, we're going to make a request to the backend to create the order. So at the top, we're going to import Axios from a string Axios. And in here, for my backend, we can send a request with the type post and the URL path /API/orders to create an order. So we'll use the code axios.post to make a request with the type post and then give it the URL path /API/orders. And that's all we need. Remember, the cart is already saved in the backend. So the backend can take that cart and create an order for us. So let's wait for this code to finish using await. And after we create an order, the backend will remove everything from our cart. So we also need to reload our cart here. First, we need to get the load cart function, and that can be found in the checkout page. So here we get load cart from the props, and we're going to share this with the payment summary. So we'll scroll down, and in the payment summary, we'll share load cart using a prop load cart equals curly brackets load cart and save. And then inside the payment summary, at the top, in the props, we'll get comma load cart. And now after we create an order, we're going to await load cart and brackets to reload the cart and update the page. Finally, after we create an order, let's also redirect to the orders page so we can see our new order. To do that, React Router provides a hook that lets us navigate to another page or go to another page. At the top, we're going to import curly brackets, use navigate from React-Router. And at the top of our component, we're going to use const navigate equals use navigate and brackets. So use navigate gives us a function, and this function lets us navigate to or go to another page in our app. So after we create an order and we reload the cart, let's navigate to the orders page using navigate, brackets, and a string, and we're going to navigate to /orders. Now, navigate is not asynchronous, so it finishes immediately, and we don't need to await this code. Let's save, and we'll go to the website and test out the place order button. So we could update the delivery option to get a shipping cost, and then click place order. And now you can see that it created a new order. you'll also see that it updated the cart, so the quantity is now 0, and it navigated us to the orders page. Once we are on the orders page, there's some code at the top of the orders page that loads the orders from the backend and updates the page. And that's how we're able to see our newest order here. So that's how we create an order. I'll leave making these add to cart buttons work as an exercise. So now we finished all the major features of our project. We can add products to our cart, we can update the cart, and we can create an order. And you'll see that in the real world, we use a backend to manage and update all the data. And in our React code, we just make requests to the backend and then update the page. The advantage of letting the backend manage the data is that it will simplify our code a lot. So now let's save this into Git. Go to the Git section, and at the top, we'll type make create order button work and commit. And now we finished all the major features of our project. In the next lesson, we'll learn how to create automated tests in React to make sure our code still works whenever we make changes. And that's the end of this lesson. In this lesson, we learned data mutation, which means to update data in the backend. We learned different types of requests, like get, post, put, and delete. We sent a post request to add products to the cart and to create an order. We sent a put request to update the cart. We sent a delete request to delete a product from the cart. We used the dependency array of useEffect to update the payment summary whenever the cart changes. We learned the useNavigate hook, which lets us navigate to another page using our code. Thanks for watching so far. If you find this course valuable, you can support the channel by liking this video, leaving a comment, and subscribing. You can also check out the premium version of this course, where you'll get all the lessons ads-free, broken down into small videos, as well as additional lessons and more projects that are not in the public React course. Currently, the premium course contains 11 lessons, and I'll be adding more lessons in the future. You can also get a certificate of completion, create comments or questions on specific topics, get progress tracking, search, and course notes. You can also check out the membership, where you can get this course ads-free, separated by each lesson, AI videos, backend tutorials, and more. Thanks again, and let's continue with the course. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to add automated tests to our app. Automated tests means using code to test our app. This is more efficient than manually opening the app and clicking around to test it. To create automated tests in React, we're going to use an NPM package. The two most popular packages for automated testing are Jest and VTest. We're going to use VTest because it integrates well with Vite, but Jest and VTest are very similar. If you learn one, you can easily learn the other. First, we're going to install VTest to our project. So we're going to go to our command line and open the tab that's running the front end, and we'll stop the Vite server using Control-C, and we're going to npm install --save-dev vtest. So save dev means that vtest is only for development. This package is not needed to run our app or to run our website. And we're also going to add @ to give vtest a specific version. So you can click this link in the description, go to lesson 9, and here you'll find the version of vtest that we'll install. So we'll copy that version and then paste it in here and press enter to install vtest. Now that we installed vtest, we're ready to create our first automated test. So there are different types of automated tests that we can create. The first type is called unit tests. A unit test means we test one unit or one piece of the code. For example, if we look at our files and we open our utils folder and open money.js, if we test a function like format money, this would be considered a unit test because it's just one piece of the code. However, if we test something like the product component here, testing components like this are not unit tests because they use many different pieces of code together. So we'll start by creating unit tests for format money. So we're going to go to this money.js file, and beside this file, we're going to create a new file for the tests. And we'll name it the same, money, but this time we'll end with .test.js. So the naming convention is to put it beside the original file and end it with .test.js. Now inside this test file, at the top we'll import curly brackets it from a string vtest. So it lets us create a test. And we'll also import the format money function from a string and import it from this file, ./money. And now to create our first test, we're going to use it and brackets, and we'll give this a string. So this creates a test, and the string here is the name of the test. So this describes what we are testing. So let's give it a name like formats 1999 cents as $19.99. If we run format money with 1999, it should give us $19.99 as the result. So this name is describing what we want to test. And a naming convention is to make this read like English. For example, it formats 1999 as 19.99. And then we're going to give this a function, brackets, arrow, and curly brackets. And in here, we're going to test if format money works correctly. To do that, we're also going to import expect from vtest. So expect lets us check if the result is correct. So in here, we're going to run expect and brackets. And in here, we put the code that we want to test. For example, let's put the code format money brackets and 1999. And then expect has different methods that we can use to check this result. One method is called .to b and brackets. So in this second bracket, we can put the expected result of this code. So we said that the expected result should be this string here. So we'll give it $19.99. So this code tests if this value is equal to this value. If they are equal, this check has passed. If they are not equal, this check has failed. And then expect is going to send this result to vtest. And vtest will display a summary of what passed and what failed. So now let's run this test. we're going to save this file. And then in our command line, we're going to create a new tab for running the tests. And first, we have to be inside the e-commerce project folder. So we'll cd e-commerce-project. And we're going to run npx vtest. So vtest is going to search our code for all the files that end with .test.js and runs the tests inside. And then it displays the result in the command line. So this tells us that our format money test here has passed. Now let's create another test for format money. We'll go back to this test file. And to create another test, we're just going to use it again. And a string. And remember that we had some problems with money not showing 2 decimals. So let's test if it displays 2 decimals. And give it a function. And now inside here, we can run expect and brackets, format money, brackets, and let's give it a value that might not show 2 decimals, like 1090. And then we'll check if this is correct using .2b and brackets and a string. And the expected result of this code should be $10.90. So we're going to check if this result is equal to this result. If we save, vtest is actually watching our files for changes. So when we save, it will automatically rerun our tests. And now you can see we have 2 tests that passed. Next, inside each test, we can have multiple checks. So in here, let's add another check using expect, brackets, and let's try format money, brackets with a different value, like 100. So we expect this to be $1.00. So we'll do .2b brackets $1.00 and save. Now vtest will rerun all of our tests, and now you can see that both tests still passed. So when we have multiple checks like this, all of the checks have to pass in order for this test to pass. If one of these checks fails, the entire test will fail and it will show up here. So as a quick example, if I change this and save, one of these checks failed, so we can see that this test has failed. So I'm going to add it back and save. Next, if we look at our file here, notice that these tests are related to the format money function. A best practice is to group these tests together. To do that, at the top, we're also going to import describe from vtest. So describe groups tests together. We call a group of tests a test suite. So above these tests, we're going to use the code describe and brackets. And we'll give this a string. And this is the name of the test suite or the group of tests. So these tests are for the format money function. And we'll give it a function, brackets, arrow, and curly brackets. And we're going to move our tests inside. So we'll select it and cut and paste and save. And everything still passes. And we can see the test suite name over here. So test suites basically help us keep our tests more organized. If we want to test a different function inside this file, we would create another test suite and group our tests in there. So a best practice is to always put our tests inside a test suite, even if we only have one test suite. So now let's save this into Git. We're going to go to the Git section, and let's use the message create unit tests for format money and commit. Next, we'll create another type of test called an integration test. Integration test means we test multiple units or pieces of code working together. For example, if we look at our files and we open the product component, testing a component would be considered an integration test. Notice this uses multiple pieces of code, like the format money function and the load cart function. So now let's create tests for this file. Beside product.js, we're going to create a new file, and we'll name it product.test.jsx. So we end with .jsx this time, because this will let us use component syntax in this file, like this. So first, let's actually copy the imports from our money test file, because we're going to be using these again. So we'll copy, and in here, we'll paste. But this time, we're going to import the product component from the ./product file. And first, we're going to create a test suite. So we use describe brackets and a string, and we're going to be testing the product component and give this a function. And inside, we'll create our first integration test using it, brackets, and a string. And for components, the first thing we can check is if the component is displayed correctly. So for the product component, we can check if the name is correct, the image is correct, and so on. So we'll name this test it displays the product details correctly. And we'll give it a function. And now inside here, how do we check if this component displayed the details correctly? So when testing a function, we run the function and check the result. When testing a component, we render the component and check the result. So render means to display the component on the page. To render the component in our tests, we need to add some more npm packages. So we're going to go to our command line. And right now, vtest is watching all of our files for changes. So we're going to stop vtest using Control-C, or you can press Q to quit. And now, we're going to click this link in the description, go to lesson 9, and we're going to install all of these npm packages that we need. So we're going to select this and copy, and then in our command line, we're going to paste this command and press enter to install all these packages. After installing, we also need to create some config files to test our components. So we'll go to our files and we'll scroll down and find vite.config.js and click it. And we're going to create a new file and name this vtest.config.js. And we'll click this link in the description and go to lesson 9. We're going to copy this setup code. So we're going to select this and copy. And then in here, we'll paste that code and save. And we're also going to create another file beside this. So here, create a new file called setup, capital T, tests.js. And we'll click the link in the description again and go to lesson 9. And we're going to copy this code and paste it in here. and save. So that's just some setup that we need to do. If we look at this config file, you don't have to worry too much about how this works. This is just some standard setup. These two are required for component tests or integration tests to work. And this basically runs the code inside this file before all of our tests. So in this file, we import just DOM, and this basically adds a bunch of methods to expect to help us test components. Now that we have these set up, we're going to go back to our test. And at the top, we're going to import curly brackets render from the package at testing-library/React. So this renders or displays a component in a fake web page, specifically for testing. Inside our test, we're going to use the render function and brackets. And we'll tell it to render the product component using less than product / greater than. So next, the product component has some props. So we need to provide these props in our test. So in here, we're going to add the prop product equals curly brackets. And we're going to provide a sample product to test with. To do that, in our files, we're going to go to the starting code folder and open the data folder and open products.js. And here we have a bunch of sample products that we can use. So let's just select the first product and copy it. And then in our test, we're going to save the sample product in a variable const product equals and paste. And we're going to take this product and save it as the product prop. Next, we also need to provide a load cart function to this component. So in our app, load cart actually contacts the backend. However, in our tests, we should not contact a real backend because the backend might not be available during tests, and our tests might accidentally update real data. So instead, a best practice is to mock this function in our tests. Mock means to create a fake version of this function. To create a mock, at the top, we're going to import vi from vtest. And we'll scroll back down and we'll create const load cart equals vi.fn and brackets. So vi.fn basically creates a fake function that doesn't do anything. So this fake function is called a mock. And we're going to give this mock to the component. So here, we'll create a prop load cart equals curly bracket and our mock load cart. And this will prevent our component from accidentally contacting the backend in our tests. And that's it. This will render the product component on a fake web page. So now, how do we check if this component was displayed correctly? We can't see the fake web page, but we can check it using our code. To do that, we're going to scroll up and we'll also import the screen from testing library/React. So screen lets us check the screen or the fake web page to see if everything was rendered correctly. In our test, after we render the component, we're going to use screen and the method .getByText and brackets. So this searches the screen or the fake web page for an element with a specific text. So we'll give it a string. And first, let's check if the product name is displayed correctly. So we'll scroll up And we're going to copy this product name. And then in here, we're going to paste. And this will search the screen or the fake web page for an element with this text inside. So now we're going to check if this element exists. That will tell us if we displayed the correct product on the page. To do that, before this code, we'll use expect and open bracket, and at the end, a close bracket, and we'll use the method dot to be in the document and brackets. So this method is added by testing library /JEST-DOM. And this checks if this element exists on the screen or on the fake web page. So now let's save, and we'll run this test using vtest. In the command line, we'll run npx vtest. And all of our tests passed. Next, let's add some more checks to this test. So let's also check if the price was displayed correctly. So here, we'll add another expect brackets, and we'll use screen.getByText and a string, and we're going to search for the price on the screen. So for the sample product, the price should be $10.90. So we'll scroll down and search for $10.90 on the screen, and we expect this dot to be in the document and brackets. And save, and Vite will rerun the test and tell us that this passed. Next, let's check if the product image is correct. So down here, we'll use another expect brackets, screen, dot, but this time we can't use getByText because we're trying to find an image. Instead, we're going to add a test ID to the image element. So in our files, we'll open the product component, and we're going to scroll down until we find the product image here. And for this element, we're going to add an attribute data-test ID equals a string product-image. So this ID lets us find the image element in our tests. We could also use the class name to find this element, but if we change our class name, it will break the test. To avoid this, we usually use an ID specifically for testing, like this. So now let's save, and in our test, we'll use screen.getByTestID and brackets, and a string, and the test ID product-image. So this will give us the image element in the product component. Now let's check if this image element's source attribute is equal to the product's image up here. So we'll select this image and copy, and then down here, dot to have attribute, brackets, and we'll check the source attribute if it's equal to the string, and paste the image from our sample product, and save. vtest will rerun our tests, and everything passed. So we know we're displaying the correct image. Next, let's check the ratings image and the rating count. Feel free to pause if you want to try it yourself first. So first, we'll do expect, open bracket, the screen dot, and we'll check the ratings image first. So we'll go to the product component, and we're going to scroll down until we find the image product rating stars, and we'll give this a data-test ID equals product rating stars image and save. And let's just select this test ID and copy. And in our test, we'll get by test ID brackets a string and paste. And we expect this dot to have attribute brackets the source attribute equals a string. And we'll go back to the product component. And let's just copy the source attribute here. So we'll select it and copy. And inside our test, we're going to paste. Now for our sample product, we have a rating of 4.5. So that means we take 4.5 and multiply it by 10. We're going to get the value 45. And this is the rating image that should be displayed on the page. So we'll save. And vtest tells us everything passed. Finally, let's check the rating count. So we'll expect brackets, screen, dot, and this time we're looking for text. So we can just use get by text, brackets, and for this sample product, the count is 87. So we'll look for the string 87. And we expect this dot to be in the document and save. Vtest will rerun and everything passed. So now we tested if the product component displayed all the details correctly. So let's save this into Git. We'll open the Git section and we'll use the message create integration test for product component and commit. Next, we're going to test user interactions. In the product component, we have an add to cart button. We can also test clicking this add to cart button to see if it behaves correctly. So in our test file, let's create a new test using it, brackets, and a string, and let's name it adds a product to the cart, and give it a function. So first, let's render the product component again. So we'll scroll up, and let's just copy all of this code. So we'll select it to here, and copy. And then in our second test, we're going to paste. So this sets up the sample product and the mock, and then renders the product component again. So now that we rendered this, how do we click the add to cart button in our test? Earlier, we installed a package called testing library/user event. This package lets us simulate events like clicking a button. So at the top of our test, we're going to scroll up and we'll import user event from the package at testing-library/user-event. So this lets us simulate events like a click. So now we'll scroll back down to our test. And first, we need to set up user event using const user equals user event dot setup and brackets. So now we can simulate events using user dot click. So this simulates a click event, and inside the brackets, we're going to tell it which element to click. So we want it to click the add to cart button. So first, we need to get the add to cart button inside our test. We'll go to our files, and in the product component, let's scroll down to the add to cart button. And we're going to give this a data-test ID equals a string add to cart button. And let's select this test ID and copy and save. And then in the product test, we're going to get the button using screen.get by test ID brackets and a string, and we'll paste the test ID. So this will get the add to cart button from the screen. So let's save it in a variable, const add to cart button equals, and we're going to give this to user.click, add to cart button. Next, when we click this button, it takes some time for the page to process the click. So user.click takes some time to finish. That means this is asynchronous code, and it returns a promise. To wait for this to finish, at the front, we're going to use await. And remember, to use await, we need to be inside an async function. So above, in this function, we're going to make it async. And we'll scroll back down. And now, once we click the add to cart button, this is going to make a request to the backend using axios.post. But remember, in our tests, we should not contact a real backend because we might accidentally update real data. So earlier, we mocked load cart and replaced it with a fake function. Now, we're also going to mock Axios, so we can actually mock an entire NPM package. To do that, at the top, we're going to use the code vi.mock brackets and the string Axios. So this mocks the entire Axios package. This means that when we are testing, when we import from Axios, we will get a fake version of Axios instead. So when we click add to cart, it will use the fake version of Axios and it will do nothing. It will not contact the backend. So now, what should we test? We can still test that our code ran axios.post, and we can test if we gave axios.post the correct values. To do that, at the top, we're also going to import Axios from the package Axios. And because of vi.mock, this is a fake version of Axios. So now we can scroll back down. And after we click add to cart, we can expect brackets axios.post. If we give a mock to expect, we can check if our code ran axios.post and if we gave it the correct values using the method .to have been called with and brackets. So we expect our code to call axios.post with /API/cart items. So in here, we'll check if the first value we gave it was /API/cart-items. And we also expect our code to give axios.post an object with a product ID and a quantity. So in here, we can also check if we gave it an object with a product ID : and we're going to get the product ID of our sample product. So here, we'll select this ID and copy and scroll back down and create a string and paste the ID. And we expect the quantity : to be 1 because we did not change the quantity selector. So this basically checks that when we click add to cart, does our code run axios.post and give it these values. So even though mocks don't do anything, we can still check if we called them and we gave them the correct values. Next, we can also check if our code ran load cart. So remember that load cart is also a mock. So we can see if our code ran load cart. So down here, we can also expect load cart, and we don't give load cart any values. So we can just use .to have been called and brackets. So this just checks if our code called load cart and does not check what values we gave it. So now let's save, and vtest will run our code, and everything still passed. So that's how we test user interactions. We create some mocks, and then we check if our code ran the mock and gave it the correct values. So now let's save this into Git. In the Git section, we'll use the message test clicking add to cart button and commit. Before we move on, we're going to do some code cleanup. Notice that in each of our tests, we have some setup code at the top, where we create some sample data and mock load cart. So we can actually share this setup code between our tests. To do that, we can move these two variables outside of this it function. So we'll select this code and cut, and outside of this function, we'll paste. Now that these two variables are outside of this function, because of scope, these can be accessed anywhere inside this outer describe function. So that means it can be accessed in both tests. So in the second test, we can just remove this setup code because now it's shared between the two tests up here. Another recommendation is to recreate shared variables before each test, because if one test modifies a variable, that change is going to carry over into the next test, which can cause bugs. So before each test, we're going to recreate these variables. To do that, we can use before capital E each brackets, and we'll give this a function, brackets, arrow, and curly brackets. So before each runs some code before each test. And also we need to import before each. So at the top, we'll import before each from vtest. So we want to recreate these shared variables before each test. So we're going to do that in here. Inside, we'll use product equals, and let's just select this value and cut. And in here, we'll paste. And because we're modifying this variable, we need to change from const to let. And we'll also recreate load cart in before each. So in here, we'll do load cart equals vi.fn and brackets. And above, we can remove this and change this to a let. So now, before each test, we're going to recreate the setup code, and we'll have a fresh set of variables. And this will make our tests more consistent. So now let's save. vtest will rerun our test, and everything still passes. So before each is known as a test hook. There are other test hooks that we can use to help us do some setup or some cleanup in our tests. So now let's save this into Git. In the Git section, we'll use the message use before each to remove duplication and commit. So we just learned how to create mocks that don't do anything. Now, we're going to learn how to mock the implementation. Mock the implementation means we make the mock do whatever we want. To do this, we're going to test another component. So in our file, we're going to go to the home page component. And here, we're going to create a new file and name it homepage.test.jsx. And let's just copy all the imports from the product component test because we'll use most of them. So we'll select this and copy. And in homepage.test, we're going to paste. And this time we'll import home page from /home page. And as always, we'll start by creating a test suite with describe. And we'll name this home page component and a function. And we'll create a test using it brackets. And let's call it displays the products correctly. Brackets, arrow, and curly brackets. And now let's render the home page using render bracket less than home page / greater than. And the home page requires two props, cart and load cart. So for the cart equals curly brackets, we're not going to test the cart right now, so we'll just set it as an empty array. And for load cart equals curly brackets, again, we'll mock load cart. So above this test, we'll create let load cart, and we'll use before each brackets and a function brackets, arrow, and curly brackets. And we'll set load cart equals a mock function, vi.fn, and brackets. And we're going to give this mock to the homepage component. Next, the homepage component is special. If we open the homepage, notice at the start, we load products from the backend using axios.get/API/products. Again, in our tests, we should not contact a real backend. So we're going to mock Axios. So here, at the top, we'll mock Axios using vi.mock brackets and the package Axios. Now, this just makes axios.get do nothing. However, in the home page, we actually need axios.get to return something because we're going to return a response, and the homepage is going to use this response to display the products. So here, axios.get cannot just do nothing. We need to mock the implementation, which means we're going to make axios.get do whatever we want. So in our test, inside before each, we're going to do axios.get.mock implementation and brackets. And we're going to give this a function, brackets, arrow, and curly brackets. So this means that in our code, whenever we use axios.get, it's going to run this fake function instead. So basically, we can make axios.get do whatever we want. That's what mock implementation means. So remember, we can give axios.get some values. Those values are going to be saved as parameters in here. So the first value we give to axios.get is the URL path. So in here, our fake function will also get the URL path. Next, inside our fake function, let's check if the URL path is equal to the string /API/products. So for the URL path /API/products, Usually, the backend returns all the products in an array. But in our test, we don't really need all the products. So let's just return 2 products to test with. So in here, we'll just return 2 products. Now, whatever we return from this fake function should match what Axios.get normally returns. So Axios.get normally returns a response with a property .data. So in our test, this mock implementation should also return an object with a property data. And normally, response.data is an array of products. So in our test, our data property should also be an array. So basically, in this fake function, we should match what Axios.get normally returns. And this makes sure that the rest of the code still works with our mock. So now in our test, let's just return 2 products to test with. To find 2 sample products, we can go back to the starting code folder and the data and the products.js. And here, let's just collapse the first 2 products and we'll select them and copy. And inside the homepage test, we're going to paste. So now in our tests, Axios.get will return these 2 products. Now there's one more thing we need to do, which is remember that Axios.get normally returns a promise that we have to await. So in our test, we should also return a promise. To make this return a promise, we can wrap this value in promise.resolve like this. Or an easier way to do this is to make this function async. So remember that async makes a function return a promise. Now Axios.get will return exactly what we want. And that's how we mock the implementation, which means we make the mock do whatever we want. Now, let's run our tests to make sure that this works. We'll save, and vtest will rerun, and we actually got an error. So if we look at this error, and we scroll up to the details of the error, you'll see that we got this error here, and it came from React Router. And this happens because if we look at our homepage component, remember that the homepage also contains a header component. And if we open the components folder and the header component, inside the header component, we have these link components. In order for link components to work, they need to be inside a router. In main.jsx, the entire app is inside a router. So that's why link components work normally. But in our test, our homepage component is not inside any router. So the link component doesn't work, and it creates an error. To fix this, we just need to put a router around the homepage in our test. So we'll go back to our test. And first, we'll scroll to the top, and we're going to import a router. So we'll import curly brackets, and we're going to import the memory router from the package react-router. So the memory router is specifically for testing. So we'll scroll down, and when we render the homepage, we're going to put it inside a memory router. So less than memory router, and we'll select the homepage and cut, and in here we'll paste, and we'll fix the indenting. And now if we save, the link components are inside a router, and now our tests should pass. Now let's check if the homepage displayed the products correctly. So after we render this homepage, because we mocked Axios to return these two sample products, there should be two products on the page. Let's add a test ID to these elements so we can get them in our test. In the product component, we're going to scroll up to the top of the HTML, and we're going to find the product container. And we're going to add the attribute data-test ID equals a string, the product-container, and save. And in our test, we're going to look for the test ID using screen.getAllByTestID and brackets and the test ID product-container. So we use all here because we're going to have multiple products on the page. So we're going to get multiple product container elements. However, there's actually a problem here. When the homepage is first created, the products are empty, so there will not be any products on the page. And we need to wait for the homepage to run useEffect and load the products, and then update the state. So to wait for homepage to finish loading, in our test, we're going to use a different method called findAllByTestID. So find does the same thing as get, but it will wait until it finds this element. So this is useful when our component needs to load something, and we need to wait for it to load. Now, because this code is waiting until it finds these elements, this code is asynchronous, and it returns a promise. So we're going to wait for this code to finish using await. And again, to use await, we need to be inside an async function. So now this will wait until it finds these product containers, and then let's save these in a variable using const product containers equals this result. And now we can check this result to see if it was displayed correctly. So down here, let's check if we have two product containers on the page. So we can expect brackets the product containers dot length dot to be 2. So this gives us an array of elements, and we're just checking if the length is equal to 2. If we save, vtest will rerun, and now this test passed. So we know we're displaying the correct number of elements on the home page. Next, we'll check inside each product container to see if they have the correct product name. Now before, we used screen.getByText to search for some text on the page. However, this searches the entire page. Here, we want to check specifically the first product container to see if it has the correct name. To do that, we can use a feature called within. So we'll scroll up, and here we're also going to import within from testing library/React. And we'll scroll back down. And within lets us find things within or inside a specific element. So to find things inside the first product container, we're going to use within brackets the product containers square bracket 0. This gives us the first product container, and we're going to search inside this container. And then here, we're going to do .getByText and brackets. And for the first container, we're going to search for the first product name. If we scroll up, this is the first product name, so we'll select it and copy. And down here, we're going to paste. So again, this searches inside the first product container for this text. And I'll add a new line to make it a little easier to read. And now we expect this to exist. So here, we'll type expect, open bracket, and just going to reformat this code a little bit. And at the end, close bracket, and use dot to be in the document and brackets. Now let's save, and vtest will tell us that this passed. So we know we're displaying the correct product in the first product container. Now let's check the second product container. We'll select this code and copy, and down here, paste, and we'll change the 0 to a 1. This gets us the second product container, and we're going to get the second product name. So up here, we're going to select this name and copy and scroll back down. And here, we're going to paste and save. And the test passed. So now we know that the second product container is displaying the correct product. Now we could check all the other details of the product as an exercise. However, we don't have to do it because remember that all the product details have already been tested in the product component test. So instead, for the homepage component, we focus on testing things that are specific to the homepage, such as rendering multiple products and loading products using Axios. So that's how we test a more complicated component like the homepage. We need to mock the implementation of Axios.get, and we may need to wrap the component inside a router. I'll leave adding more tests for the homepage as an exercise. So now let's save to Git. We'll open the Git section, and we'll use the message create integration test for home page and commit. So now, whenever we make changes to our code, we can run these automated tests to make sure that format money, the product component, and the home page are still correct. Now, usually we create tests for all of our components, but I'll leave that as exercises. In the next lesson, we'll learn deploying, which means how to put our React app on the internet. And that's the end of this lesson. In this lesson, we learned how to create automated tests with vtest. We learned how to create unit tests, which test one piece of the code. We learned it, expect, and describe, which lets us create a test, check the results, and group the tests together into a test suite. We learned how to create integration tests, which test multiple pieces of code working together. We learned how to test a component using render and screen. We learned how to create a mock, which is a fake version of a function or a package. And we learned how to mock the implementation, which means we make a mock do whatever we want. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn deploying, which means how to put a React app on the internet. So there are many services we can use to deploy. In this lesson, we're going to use AWS, or Amazon Web Services. AWS is the biggest service for putting websites on the internet. Most big tech companies use AWS, so it's the most useful to learn for your career. So AWS stands for Amazon Web Services. it's a collection of services that help us put stuff on the internet. And AWS has a free tier where we can use many of their services for free using some credits. So let's click this link in the description, go to lesson 10, and here we have a link to AWS. Now, before we begin, AWS might change their website design in the future. If you have any issues, please check this AWS troubleshooting guide here. Now let's get started with AWS. We'll click this link to open AWS, and the free tier is free for new accounts. So we're going to create a new AWS account. If you don't see this, you can also click Sign In, and then scroll down and click Create a new AWS account. Before we continue, because AWS is the biggest web service, it has to follow a lot of security and compliance regulations. So even though it has a free tier, it will ask you for a credit card, billing address, and phone number when signing up. If you're unable to provide this information, please check the AWS troubleshooting guide in the description. However, I still recommend at least watching this tutorial to see how AWS works, since it's the most useful for your career. So here, we'll enter our email address for logging in. So for me, I'll use this email. And then we'll go through the rest of the sign up process. After signing up, it might take a few minutes for the account to be activated, so we just need to give it a bit of time. Now that we created a new AWS account, one thing to note is when signing into AWS, if you see an account ID and IAM here, we're going to click this Sign In with root email button. And then here, we can sign in with the email and password we created earlier. After signing in, you can see the details of the free tier here, or by clicking here. After we sign in, we're going to land on this AWS dashboard. So as I said, AWS is a collection of services that help us put stuff on the internet. So here, we can see all the services that are part of AWS, and there's a lot of services. At the top in the search bar, we can search for a service. So we're going to start with the most basic service called EC2. And click here to open it. EC2 stands for Elastic Compute Cloud. It basically lets us rent a computer from AWS. Earlier in the course, I mentioned that many websites use a backend to manage the data, and the backend is another computer on the internet. Now, we could buy a physical computer ourselves and use that as the backend, but then we have to keep this computer running 24 hours a day and put it in our office somewhere. So this is a lot of work. And what most companies do is they just rent a computer from AWS. And AWS will manage the computer and keep it running 24 hours a day. And this saves a lot of work. So EC2 basically lets us rent a computer from AWS. This is called Infrastructure as a Service, or IaaS. This means that AWS manages the infrastructure, or the computers, for us. So to rent a computer in here, we can click the Instances section, and then click Launch Instance. By the way, one instance is one EC2 computer. However, we're not going to use this because there's still some problems with this process. EC2 just gives us a computer. We still need to install Node.js on this computer. We still need to connect this computer to the internet, and we need to upload our code to this computer. So even though AWS manages the computer, there's still a lot of manual work we have to do. To solve this problem, AWS provides another service. At the top, we're going to search for Elastic Beanstalk and click here to open this service. You can think of Elastic Beanstalk as a layer on top of EC2. It uses EC2 to rent a computer, but it also installs all the software we need on this computer, and it connects the computer to the internet. So Elastic Beanstalk also does all the software setup for us. All we have to do is just upload our code to Elastic Beanstalk, and it will just work. This is called a Platform as a Service, or a PaaS. This manages the infrastructure and the software for us. If you want to learn more about these concepts, you can check out my backend overview video in the description. Now that we have an overview of AWS and some of the services we can use, let's learn how to use Elastic Beanstalk. Now, Amazon might change the design of these pages in the future. If you run into any issues, make sure to check the AWS troubleshooting guide in the description. We're going to start by creating an application, or we can click here, click Environments, and Create Environment. And on this page, we're going to select a web server environment, and we're going to give a name to our application. So let's just use e-commerce-project-react. And we can use the default values for this section. And we'll scroll down. And for the platform section, we're going to choose the technology we want to use here. For us, we're going to use Node.js. And down here, we'll just use the sample application. We can upload our own code later. And we'll scroll down. And here, we'll choose single instance. If you see free tier eligible, pick that one. Otherwise, just pick the single instance. And then here we'll click Next. And here we need to create a role. A role gives Elastic Beanstalk permission to use other services in AWS. So in here, if you already have a role for Elastic Beanstalk, you can use that. Otherwise, we'll click Create Role. And we should be able to use the default values that they set here. And we'll click Next. And then click Next. And at the bottom, we'll click Create Role. And then we'll go back to Elastic Beanstalk. And we'll click this button to refresh. And we'll select the role that we just created. For this one, we also need to create a role. So we'll click here. And then we can also use the default values that it gives. Click Next. And Next. And at the bottom, Create Role. And we'll go back and refresh and select the role that we just created. And we can keep this as blank. And we'll click Next. For the networking and database settings, we can just use the default values here. So we'll scroll down and click Next. And for the instance settings, we're going to scroll down and find the section called Capacity. And down here, we're going to scroll down. And we're going to find a section like this called Instance Types. And it has a drop down here. So this lets us choose the size of the computer that we want to rent from EC2. So in the description, we're going to click this link and go to lesson 10, and then follow the instructions here to select the correct instance types. So now we'll scroll down and click Next. And we can leave monitoring and logging settings as the default. So we'll scroll down and click Next. And finally, we'll scroll to the bottom and click Create. So now Elastic Beanstalk is going to rent a computer for us using EC2. It will also install all the software that we need on this computer, like Node.js and NPM, and it will do all the configuration to connect this computer to the internet. So this will take a few minutes to complete. So we need to wait for this to finish. And you might need to refresh the page to check the progress. Once that's done, it should look something like this. And we can click this URL here or click here to open this website. And now we should see a sample Node.js application on this page. If something goes wrong and this doesn't work, please check the AWS troubleshooting guide in the description. Now that we set up Elastic Beanstalk, we're ready to put our code on the internet. We'll go back to Elastic Beanstalk, and our code has two parts, the backend and the front end. We put the backend on the internet first, and then we put the front end. To put the backend on the internet, we just need to upload our backend code to Elastic Beanstalk. So we'll click Upload and Deploy. And here, we're going to upload our backend code. However, we need to upload the code as a zip file. So we'll go back to VS Code, and I'll collapse this for now. And I actually set up the e-commerce backend so that it works with Elastic Beanstalk. So this backend has a command that will save all the code in a zip file. So we're going to go to the command line, and we're going to create a new tab. And in here, we're going to cd into e-commerce backend, and we'll run the command npm run zip. So this will save all the backend code into a zip file, which is right here. If I open this zip file, you'll see that it just contains all of the backend code. So now we just need to upload this zip file to Elastic Beanstalk. We'll go back to the browser, and we'll click this to choose a file. And for me, my code is on the desktop inside the React course folder, inside e-commerce backend. And if I scroll down, I'll see this e-commerce backend 1, which is a zip file. So I'll click this and open, wait for it to upload, and then click deploy. So now Elastic Beanstalk will take the backend code and put it on the internet. So we'll wait for a few minutes for this to complete. Once that's done, we're going to click this URL again. And now, instead of the sample application, it should say index not found, which is normal. This is how I designed my backend. Now, in the URL, we're going to click up here and go to the end. We're going to enter the URL path /API/products and press enter. So this will give us the products data that we were using in our project on our computer. So this is the same data that we saw before, except now our backend is on the internet. Now that our backend is on the internet, let's put our front end on the internet as well. For the front end, we also need to prepare our code. So we'll go back to VS Code, and I'll collapse this folder for now. And if we look at the front end code, notice that in here, we use .jsx code. However, remember that the browser does not understand JSX. It only understands normal JavaScript. So we need to convert this code into normal JavaScript first. To do that, Vite has a command for this. Inside the command line, we'll create a new tab, and this time we'll cd into e-commerce-project. And Vite has a command called npm run build. This is a shortcut for Vite build. So we'll press enter. And this basically converts all of our JSX code into normal JavaScript and saves the code in a folder called dist. So inside here, we have an index.html file, and this is the HTML for our React website. And inside the assets folder, we have this JavaScript file. So this is all of our React code, but converted into normal JavaScript. You'll also notice that Vite combined all of our code into one file, and it also minified or compressed the code. So it shortened the variable names and removed the extra spaces. This is because when we open a website, our browser needs to download all the front-end code and run it. By combining and compressing the code, it makes our website load faster. And Vite did the same thing with the CSS. You can see that it combined all of our CSS files together and compressed it. So now our frontend is optimized and it's ready to be put on the internet. So now when we open a website, we need to download this React code from somewhere. So where do we put this front-end code? So we could put this in another service like GitHub Pages, and then when we visit the website, our browser will download this front-end code from there. However, notice in our current setup that we already have this backend computer that's running in Elastic Beanstalk. So we can just reuse this backend computer. We can put our React code into the backend computer, and our browser will download the React code from the backend computer. So this is a common setup, and it simplifies our setup because now we only need to set up one computer. So to do this step, all we need to do is to take this dist folder and then drag it into the e-commerce backend like this. And I added some code in the e-commerce backend so that it works with this dist folder. So now in the command line, we'll go back to the tab that's running in the backend, and we're going to create the zip file again. So we'll do npm run zip. So this will create another zip file, but with our front-end code inside. And now we just need to upload this to Elastic Beanstalk. We'll go back to the browser and open Elastic Beanstalk, and we'll click Upload and Deploy. And we'll choose a file. And this time, we'll choose the second file here. And click Deploy. And we'll wait a few minutes for this to complete. Once that's finished, we're going to click this URL again. And now we should have our React app on the internet. So let's try adding some stuff to the cart to make sure it works. I'll add a toaster and 2 plates. And now if I look at the cart, it updated. If I open it, we have our new products in the cart, and we can update them like usual. And if we click Create Order, it works. So everything is working the same as on our computer, but this React app is now on the internet. If we go back to the home page, I'm going to give you an overview of how this works. So visually, this is what's happening. First, we put our backend on the internet, so the backend is running on a separate computer. And then we put our front-end code in the backend computer. And I set up some code in the backend so that when we visit the website using the URL path /, the backend sends back the React code to our computer. So now we have the React code running on our computer, and it communicates with the backend running on another computer. So this is how a real-world React app works. When we're developing, the front end and the back end run on the same computer, because it's easier for development. But when we put the React app on the internet, the front-end code runs on our computer and the back-end code runs on another computer. Next, we can add a shortcut to Vite to make this process a little easier. We'll go back to VS Code and we'll go to the e-commerce project folder, which is here. So remember that we created a dist folder and then manually dragged it into e-commerce backend. We can configure Vite to put the dist folder in e-commerce backend directly. We're going to scroll down to vite.config.js. And in this configuration, at the bottom, we're going to add a property called build, colon, curly brackets. And in here, we'll use the property out, capital D, dir, colon, and a string. So this tells Vite where to put the dist folder. So we want to put it inside the e-commerce backend folder. So we'll give it .. to go out of e-commerce project and then into e-commerce -backend/dist and save. So now if we go into the backend and we right click and delete this dist folder and then run npm run build, so in the command line, we'll open the tab that's running in the e-commerce project and then run npm run build and press enter. It will create the dist folder directly in here, so directly in the e-commerce backend. So this just saves a step in our process. We can also automate this process further, but I'll leave that as an exercise. So now we'll save this change into Git. We'll go to the Git section and we'll use the message save build result in e-commerce -backend and commit. Before we continue, I want to discuss how to deploy a React app without a backend. So notice that so far, to put a React app on the internet, we needed a backend. But what if we don't know how to write backend code yet? What if we just know React? So if a React app does not have a backend, we can actually just put the code on the internet directly. For example, in our code here, we're going to go back to our chatbot project from earlier. And notice that this project does not use a backend. It only has React code. So to deploy this project, we're going to use npm run build again. So in our command line, we'll create a new tab and we'll cd into the chatbot-project folder. And if we need to, we can npm install and then npm run build. And this will convert all the React code into normal JavaScript and save it in a dist folder again. So notice that inside the dist folder, we actually just have normal HTML, CSS, and JavaScript code. So this is actually just an HTML website. And we can actually upload this code to any service that puts an HTML website on the internet. For example, here I use a service called GitHub Pages. And I can just upload this code to GitHub Pages and it will put it on the internet. No backend knowledge required. To learn more, you can actually follow the same steps as my video, how to put a HTML website on the internet. However, make sure you do the exercises in this lesson first, since there's still some small configuration changes that we need to make for this to work. So basically, if we just have a front end, we can just upload this code directly to the internet using something like GitHub Pages. But if our project has a backend as well, then we need to use a more complicated service like AWS to put the backend and the front end on the internet. In the rest of this lesson, we're going to improve our AWS setup to make it more real-world and professional. So we'll go back to the browser, and we'll open AWS again. And I'm actually going to close some of these other tabs because we don't need them. And inside Elastic Beanstalk, in this project, we're going to go to the configuration section. And we're going to scroll down and find the configuration for instance traffic. If you don't see this, you can check the AWS troubleshooting guide in the description. So here we'll click Edit, and we're going to scroll until we find the capacity section. And here we'll look for something like environment type and a dropdown that says single instance. So we're going to change this to load balanced. So what this does is it adds another computer in front of our backend computer. This is called a load balancer. So what a load balancer does is if we have a really busy website, one computer might not be enough to handle all the requests. So we can actually run the backend on multiple computers. And this load balancer will distribute the requests across these computers. This allows our website to handle much more users. So here, we can decide how many backend computers to run. Since we're just testing, we'll set this to a minimum of 1 and a maximum of 1. And then we'll scroll down and click Apply. And now Elastic Beanstalk will set up a load balancer computer in front of our backend. And this will take a few minutes to complete. After it finishes, we're going to go back to the configuration again. And we'll scroll down to the instance traffic settings and just make sure that min is 1 and max is 1. If it's not 1, we can click Edit and then scroll back down and then change it to 1. And we'll scroll down and click Apply again. So when that finishes, I'll just check it again. And now it's 1 and 1. So now our website setup looks like this. We have 3 computers, the front end, the back end, and the load balancer. This is closer to a real-world setup. Again, you can watch my video on backend overview to learn more about these concepts. Next, currently all the data for our React app, like the products, the cart, and the orders, are saved in a database, and the database is saved in a file. However, when we put our React app on the internet, we usually put the database on a separate computer. And this lets us share the data between backend computers. So inside AWS, we're going to go to the configuration again. And we'll scroll down to the database configuration. And we'll click Edit. And inside the database section, we're going to scroll down and find Database, and we'll click Enable Database. Elastic Beanstalk will automatically create a new computer that's running a database, and it will connect this database to our backend. So we'll scroll down and look at these options. And here, we can select the database that we want to use. So the e-commerce backend works with the database MySQL. So we're going to use that. And then here, we're going to look at the instance class setting. So this is the size of the computer running the database. In the description, we'll click this link, go to lesson 10, and then here, we'll follow the instructions to select the correct instance class for the database. And finally, we'll set a password. And now we'll scroll down to the bottom and click Apply. So AWS will set up a separate computer to run the database. And I already added some code in my e-commerce backend to connect to this database. So it should just work. If you have issues, please check the AWS troubleshooting guide. After that finishes, we can open the website again. And it still works. If we add something to the cart, notice that the database still works. And if we open the orders page, remember that earlier I created a new order? And now the orders are back to the default values. So this means that we're using the new MySQL database that we set up. And now our AWS setup looks like this. We have a load balancer, a backend, and it connects to a database on another computer. And this is getting even closer to a real-world setup. Next, if we go back to AWS, notice that to open our website, we use this default URL, which is really long. So now we're going to set up a domain name to make our website easier to access. A domain name is like mywebsite.com or youtube.com. It's a short name that makes it easy to access our website. So instead of putting this long URL in the browser, we can just type mywebsite.com and it will open this website. So I'll show you how to set up a domain name with AWS. First, we need to purchase a domain name. Most domain names cost around $10 or $20 per year. So this section is optional. If you already have a domain name that you purchased before and you want to use, feel free to skip to the next section. Otherwise, I'm going to show you how to purchase your own domain name. There are many services we can use to purchase domain names. I use a service called Namecheap for all my websites, like supersimple.dev. In the description, we'll click this link, go to lesson 10, and click here to go to Namecheap. So this is an affiliate link. If you decide to purchase a domain name using this link, part of your purchase will help support this channel. Thank you so much. Once we're on Namecheap, we're going to search for a domain name that we want. If you see a search box here, you can search for it. Otherwise, we can go to Domains and Domain Name Search. And we'll scroll down here and search for a domain name. So domain names are unique. Once they are taken, like youtube.com, we can't purchase it anymore. If you don't know what domain name you want, my recommendation is to try to register your first and last name. This might be useful for a personal website. So for me, it's Simon Bao, and we need to give it an ending, like .com. .com stands for commercial. It's the most popular ending for domain names. Now, you could pick another ending that you want, but be careful because some domain endings don't work with normal browsers. If you're not sure which ending you want, I recommend using .com or .net, just to be safe, because they are the most popular. So now, I'm going to click Search to see if this domain has already been taken. So it looks like this one has already been taken. So I'll just add something to it, like Simon Bao Eng or engineer. And this one is available. So you might need to modify your domain name to find one that works for you. So we'll add this to the cart and then open the cart. If you want to auto-renew this domain name, you can click here, and then we'll click Confirm Order. And if you don't have a Namecheap account, you'll need to create an account first. And after filling out all the information, we'll purchase the domain. And that's it. Now we have a domain name and we own a little piece of the internet. Once we have a domain name, we're going to set up the domain name in AWS. So we'll go back to AWS, and at the top, we're going to search for the service Route 53. And we're going to right-click this and open in a new tab. So Route 53 lets us manage our domain names in AWS. We can click Get Started and click Create Hosted Zones, and then click Get Started. If you don't see that, we can also click this menu here, click Hosted Zones, and then click Create Hosted Zone. A hosted zone lets us connect a domain name to our app. So currently, a hosted zone costs about 1.6 cents per day. So you can use it for free for a few hours. So here, we're going to enter the domain name that we have. So for me, it's simonbaoeng.com. And scroll down, and we'll leave it as a public, and then click Create Hosted Zone. And now, inside here, we're going to scroll down and click Create Record. So this sets where the domain name will go. We're going to leave the subdomain as blank, and we'll create an A record, and we're going to check alias. And here, we can select which AWS service we want to connect to. So for us, we're using Elastic Beanstalk, and we're going to choose the region. If we go back to the tab that's running Elastic Beanstalk, we can see the region up here. So for me, I'm using the region Ohio. So I'll go back to Route 53, and I'll search for the region Ohio, and select it. And we should see our app here. So I'll select that. And then scroll down and click Create Records. And finally, we need to tell Namecheap, or the company that you use for your domain name, to redirect to AWS. So inside Namecheap, or your domain company, we're going to go to the settings, and we're going to find the domain. So in Namecheap, it's in domain list. And here, you may need to verify your email. So we'll click this and check your email for the verification. So this might take a while, so we just have to wait until the verification is complete. And we may need to log out and log back in to our Namecheap account for the verification to update. Once verification is complete, we should be able to go back to the domain list, find our domain, and open the settings for the domain. And in the settings, we're going to look for a section that's called Name Servers. If you're having trouble finding this in Namecheap or your domain company, please check the AWS troubleshooting guide in the description. And then in here, we're going to click this dropdown, and we're going to set custom DNS because we're going to use AWS for this. So now we need to enter some name servers. To find these, we're going to go back to AWS Route 53, and I need to zoom out a little bit to see this. Inside the hosted zone, we have some records here, and we're going to look for the record NS, or name server. So in the NS record, we should see these 4 URLs here. So we just need to copy these over to Namecheap, or your domain company. So we'll select this and copy. And then inside Namecheap, in here, we'll paste. And we'll go back and select the second name server, copy, and paste. If we need to, we can add 2 more name servers. In here, we'll select this and copy. And here, we'll paste. And we'll select the last one, copy, and here, paste, and then save. So what this does is when we open our domain name in the browser, Namecheap is going to redirect to AWS. And then AWS will redirect to Elastic Beanstalk or to our app. So this setting will take a while to update. Sometimes it finishes in just 10 minutes, but it could take up to 24 to 48 hours. So we just have to be patient. So once we waited for a while, we can try opening a new tab. And in here, we'll type http:// and our domain name. So for me, it's simonbaoeng.com and press enter. And this will redirect to our app. So now we're able to access our React app using a short domain name that's easy to remember. Next, I'm going to explain why we enter HTTP in front and why we see this not secure warning here. So this means that our website is not using encryption. This means that any data we send to this website can be intercepted by a hacker. To enable encryption on this website and make it secure, we need to set up an SSL certificate, which is a special file that enables encryption. To get an SSL certificate, we can use AWS. So we'll go back to AWS Route 53, and then at the top, we'll search for another service called Certificate Manager, and click here. And we can request a certificate. If you don't see it, you can also go in here and click Request Certificate. We'll use the default value and click Next. And here, we're going to enter our domain name. Make sure to enter your domain name. And we'll scroll down and make sure DNS validation is selected. And scroll down and click Request. And then we'll wait for this to finish loading. And now, AWS needs to confirm that we own the domain name. That's why it says pending validation. To do that, we can just click this Create Records in Route 53 button. If you don't see this, please check the AWS troubleshooting guide. And it should show up here, and we'll click Create Records. And we'll wait for this to finish. We may need to refresh a few times until it says it was successful. And now that we have an SSL certificate, we can use this in Elastic Beanstalk. So we'll go back to Elastic Beanstalk, and then in the configurations here, we're going to scroll down to the instance traffic settings and click Edit. And we're going to scroll down until we find this Listeners section. And here, we'll click Add Listener. For the port, we're going to use 443. And for the protocol, we're going to use HTTPS. HTTPS means we're going to have a secure connection to our website, and this usually uses port 443. And here, we're going to choose the SSL certificate that we just created. And we should be able to leave the SSL policy blank and click Save. If that didn't work, please check the AWS troubleshooting guide. So this basically adds an SSL certificate to the load balancer. And now any data sent to our website will be encrypted. So we're going to scroll down and click Apply. And again, this will take a few minutes to complete. So we just have to wait for it. Once that's complete, I'll close some of these other tabs and I'll create a new tab. And in the URL, we're going to type https://. So this tells the browser to use the secure connection to our website. and then we'll type our domain name. For me, it's simonbaoeng.com and press enter. So now the not secure warning is gone, and we're using a secure connection to our website that uses encryption. Also, now, if we just type our domain name in the URL without HTTPS in front and press enter, it will default to using the secure version. So that's how we set up an SSL certificate and HTTPS in AWS. And now we have a professional and real-world setup for our React app. In this section, I'll show you how to delete everything we created in AWS. However, I recommend to do the exercises of this lesson first to get more practice with AWS and then do this deletion. Also, I try to keep everything we created in the free tier. The only exception is the hosted zone in Route 53. You can use it for free for a few hours. So you could keep running these services and practice AWS if you want. To check your AWS bill, we can go to the profile and click Billing and Cost Management. And now, after you finish the exercises, I'll show you how to delete everything just in case. So in Elastic Beanstalk, we can click this Actions dropdown and click Terminate Environment. And in here, we need to type the name of the environment, which is here, and click Terminate. Once that's finished, we can go up here and go to Route 53. And in this menu, we can go to Hosted Zones, and we'll open the hosted zone. And inside here, we're going to select the A record and the CNAME record and delete these records. And then at the top, we can delete the hosted zone. And in here, we'll type delete and click delete. Once that's finished, at the top, we'll go to Certificate Manager. And in this menu, we're going to click List Certificates. And we'll select this certificate and click Delete. Type delete and click delete. You can also delete your entire account if you want by clicking your profile and clicking account, and then close account, although you'll lose access to the free tier if you do this. I usually keep my account open for a while to practice with the free tier. So now we put our React app on the internet and we created a professional real-world setup. And that's the end of this lesson. In this lesson, we learned AWS, or Amazon Web Services, which is a collection of services that help us put stuff on the internet. We learned EC2, which lets us rent a computer from AWS and is known as Infrastructure as a Service, or IaaS. We learned Elastic Beanstalk, which manages EC2 and sets up all the software that we need. This is also known as a Platform as a Service, or PaaS. We put our backend on the internet. We learned how to build and optimize the front end and put it on the internet. We learned how to deploy React without a backend. We added a load balancer and database to create a more real-world setup. And we learned how to set up a domain name, SSL certificate, and HTTPS for our website. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn some of the updates in the new version of React, and we'll learn how to use TypeScript with React. On the React website, there's a page that lists the updates in the new version of React. You can find a link to this page in the description. So there's a lot of changes here, and many of these changes are related to using React in a framework, which is basically a layer on top of React. For now, I'm just going to go over the changes that are related to this course. The first change is called Support for Document Metadata. So this means that we can put elements that normally go inside the head section, like the title, link, and meta elements, directly inside our component, like this. So this lets us change the head section when we render this component. For example, in our project, we used a title element to change the text in the tab when we switch pages. The way this works is when this component renders, React will put this title inside the head section, and this will change the text in the tab. Before React 19, we had to use an NPM package like React Helmet to do this. After React 19, we can just put these elements directly in our components, so it's easier. Another change is called ref as a prop. Earlier in this course, we learned about refs, and we can use a ref to get access to an HTML element directly. We can also give a ref to a component. For example, if we want to get an HTML element inside this component. Before React 19, ref was a special prop. We can't access it inside this component. We had to use a feature called forward ref. After React 19, ref is now a normal prop. We can access it like any other prop, and we don't need to know about forward ref anymore, so it's easier. The next change is the introduction of the React compiler. The React compiler optimizes our React code. For example, let's say we had a component like this. We have a counter and two other components inside. When we click the counter, this element will update, but it will also recreate these other two components, even though clicking the counter does not affect the other two components. That's because by default, when a component updates, it will also update or recreate all the components inside. And this may cause performance issues. To avoid this issue, before React compiler, we had to use three features: use memo, use callback, and memo. And this prevents a component from being recreated unless one of the props changed. So don't worry if you don't understand this code, because after the React compiler, the compiler will just add these optimizations automatically. And now we can just write our code as normal, and we don't need to worry about use memo, use callback, or memo anymore in most cases. So again, the React compiler optimizes our React code. All we have to do is to set up the React compiler, and we will get these optimizations. We don't have to change any of our code. Now let's learn how to set up the React compiler in our project. In the description, we'll click this link, go to lesson 11, and here we have the instructions for setting up the React compiler. I put the setup instructions here because this process might change in the future, and it's not easy to update the video. So follow the instructions that you see on your page. For me, the first step is to install the React compiler npm package. So I'm going to select this command and copy it. And then in my project, I'm going to go to the command line and create a new tab. And I'll close these other tabs so that I can start fresh. And first, I need to make sure I'm running inside ecommerce-project. So I'll cd ecommerce-project. And then I'll paste the command and press enter to install the React compiler npm package. And then I'll go back And the next instruction is to copy this React config. So I'll select this config and copy it. And then I need to update vite.config.js and put that React config in here. So I'll go to the project and open vite.config.js. And at the top, I see this React config. So I'm just going to replace it and paste and save. And that's the setup. Again, the instructions might be different when you watch this video, so follow the instructions on your page. Next, let's check if the React compiler is working. So we'll go back to the instructions. And down here, we have some instructions for checking if React compiler is working. Again, follow the instructions on your page because they might have changed. So first, I'll start the backend and the frontend using npm run dev. I'll go back to VS Code, and in the command line, I'll create a new tab, and I'm going to go into the backend folder using cd ecommerce-backend and run npm run dev. And I'll go to the frontend tab, and I'll also run npm run dev. So now both of them are running. I'll go back to the instructions. And the next step is to install the React DevTools Chrome extension. So we'll click here. So this is an extension made specifically for React. It has a bunch of features that help us with React development. So here, we're going to add this extension to our browser. And once that's finished, I'll go back to the instructions. And the next step is, in your project, open the console and open the Components tab. So in VS Code, we're going to open this project in the browser. And I'm going to right-click and inspect. And in the console, we're going to click here, and we should have a new Components tab. So we'll click this. If it gets stuck, you can refresh. And this shows us all the React components that are on our page. If we scroll down, and if we look at our components, they should have a badge beside them called Memo. This means that the React compiler is working, and it's optimizing our React components. Now let's go back and look at some more changes in the new version of React. The next change is removed prop types and default props. So prop types were an older feature of React. It basically lets us check the type of a prop. For example, here we can check if the prop text is a string. If we run this app and text is not a string, it would show a warning in the console. So now we use a different tool called TypeScript, which is better at this type of type checking. So React removed the prop types feature in favor of TypeScript. React also removed default props. If a prop is undefined, this feature lets us set a default value. So now we can do this with normal JavaScript. So we don't need this React feature anymore. Now that we learned that prop types was replaced by TypeScript, let's learn how to set up TypeScript with React. We'll go back to VS Code. And to set up TypeScript with React, we can use the create vite command. So in the command line, we'll create a new tab and make sure this is running in the React course folder. And we're going to run the command npx create-vite. And we'll type @ to give it a specific version. And we'll click this link in the description, go to lesson 11, and we'll use this version of Vite. So copy the version that you see on your page, and in here we'll paste and press enter. If it asks to install the package, press Y and press enter. And as a review, Create Vite creates a new project. So let's name this project e-commerce-project-ts or TypeScript and press enter. For the framework, we're going to press down and choose React. And for the variant, we're going to choose TypeScript. So this will create a new React project that uses TypeScript. If we look at the code inside source, notice that it uses TSX files instead of JSX. TSX means this code uses TypeScript, while JSX means it uses JavaScript. So now to run this project, we're going to follow the instructions that we see. So for me, I'll cd into e-commerce-project-ts and run npm install to install all the packages that we need. And then I'm going to open the tab that's running the front end, and I'll press Ctrl+C to stop the front end so we don't have any issues. And then in the TypeScript tab, we're going to run npm run dev to start this project. And now we'll open this in the browser. So I already have it open. So I'm going to go in here and open this tab and refresh. Now we have a new React project, but this project uses TypeScript instead of JavaScript. And now I'll give you an intro to TypeScript. Let's go back to our code. And inside the TypeScript project, we're going to open app.tsx. So first of all, what is TypeScript? TypeScript is just JavaScript with extra features. So notice that this TypeScript code is the same as JavaScript code. The syntax is the same, and the features are the same. For example, in here, in TypeScript, we can create a variable the same way as JavaScript using const message equals the string hello. And then we can console.log message. So as you can see, TypeScript is just JavaScript. However, TypeScript gives us some extra features on top of JavaScript. The main feature is we can add types to our variables. So what are types? Remember that JavaScript has different types of values, like numbers, strings, and objects. In TypeScript, we can set what type of value is inside a variable. For example, in this variable, we have a string. So after the variable name, we can type colon, space, and string. So this tells TypeScript that this variable contains a string. So now below this, if I type message and then dot, TypeScript knows that this is a string. So now it's able to suggest all the features of a string, like to lowercase and brackets. So using TypeScript, our computer can give us better autocomplete suggestions. Next, if I type message dot to fixed and brackets, to fixed only works with numbers. Because TypeScript knows that this is a string, it's going to give us an error saying that toFixed does not work on strings. So this feature is called type checking. TypeScript checks if this code works with this type of value, and this helps us avoid errors. In JavaScript, there is no type checking. So if I want to put this code on my website, JavaScript will just let me do it, and it will crash my website. But in TypeScript, if I want to put this code on my website, I would save this code, and then in my command line, press Ctrl+C to stop the server, and run npm run build. Notice that TypeScript actually blocks us from building this code and putting it on our website because there's an error with the types. So as you can see, TypeScript gives us type checking, which helps us avoid a lot of these coding errors and helps us keep our code safer. Another feature of TypeScript is type inference. Type inference means TypeScript can figure out the type automatically. For example, in this code, this variable obviously contains a string. So we actually don't need to set the type manually here. If we delete this type, TypeScript will infer or figure out that this is a string. So I can remove it and save, and the error check still works because TypeScript knows that this is a string. Another example of type inference is up here in useState. So this count variable contains the number 0. TypeScript will infer or figure out that count is a number. So if we do count.toLowerCase and brackets, it's going to give us an error because toLowerCase only works with strings, and TypeScript figured out that this is a number. So as you can see, TypeScript is just JavaScript, but it adds extra features like type checking and type inference to our code. And this helps us find and avoid errors. So now let's save this code, and we'll save these changes into Git. In the Git section, at the top, we're going to use the message create new React TypeScript project and press commit. So we just learned how to create a new React project that uses TypeScript. Now let's learn how to convert an existing project, like our e-commerce project, to TypeScript. To do that, we're just going to move all of our changes over to the new TypeScript project. Before we begin, if you have any issues during this process, please check the troubleshooting guide in the description, since things might change depending on the version of Vite. To make this easier, in the e-commerce project, we're going to delete the Node modules folder for now. And then we'll make a copy of this folder. So we'll right-click, copy, and we'll collapse these folders and click the outside and right-click and paste. So this just helps us keep track of progress when we're moving the changes over. So we're going to start from top to bottom. First, we'll look at the public folder. So in here, the change we made is we added this images folder. So we're going to take the public folder and we're going to drag it to the TypeScript project and click move and click replace. Next, let's go into the source folder and we're going to move our changes over one by one. So first, in the assets folder, we didn't make any changes to this folder, so we're not going to move it over, and we can just delete this folder. As a reminder, we're not trying to move all of our code over. We want to start from a default TypeScript project and then only move our changes over to the new project. So let's continue and look at the components folder. So this folder is completely new. So we're going to move this entire folder over to the TypeScript project inside the source folder. And click move. And if it asks to update the imports, we're going to click no, because we're going to move everything over. Next, we're going to go back up, and the pages folder is new. So we're going to drag this folder into the TypeScript project inside source. And click move. And update the imports, click no. Next, we'll scroll up, and the utils folder is new. So we're going to select this folder and drag it into the TypeScript folder inside source. So move and click no. And next, we'll keep going one by one. For app.css, we made it empty. So we're going to move this over. So drag it into source, click move, and click replace. And scroll back up. For app.jsx, we made a bunch of changes in here. So we're going to move this over. So drag it into source and click move. However, notice in the TypeScript project, the file is called app.tsx. So we're going to replace this code with our file. So first, we're going to select this and delete app.tsx. And then we'll right-click app.jsx and rename it to tsx. Now we'll scroll back up and continue moving our changes. So index.css, we completely changed this file. So we're going to move it into the TypeScript project, into source, click move, and click replace. And scroll back up. And finally, in main.jsx, we just added the router. So let's move this file as well. We'll select it and drag it into source and move. And again, in TypeScript, the file is called main.tsx. We'll select it and delete. And we're going to rename our file. Right-click, rename, main.tsx, and press enter. Update the imports, select no. We'll scroll back up, and we moved all of the code from the source folder, so we can delete it. Next, we don't need to move the starting code folder because this was just for practice when we were setting up this project. So we can just delete this folder. Now let's move all the files over to the TypeScript project. So in git ignore, we didn't make any changes to this file, so we don't need to move it over, and we can delete it. In eslint.config.js, we added one change to this file at the bottom, which is we added this rule to disable prop types. So we'll select this code and copy. And in the TypeScript project, we're going to open eslint.config. And at the bottom, in this rules object, we're going to paste and move that change over and save. So again, we don't want to move all of our code over. We just want to move the changes over because a lot of this code is specific to TypeScript. So we'll scroll back up here and we can delete this file because we moved it over. Next, let's keep going in here. For index.html, we changed a few parts of this code. So we're going to move these changes over. To help us compare this code with the TypeScript version, I'm going to scroll down and take this index.html and then move it at the bottom here so that I can compare these side by side. So first, the first 3 lines here, we did not make any changes, so we can skip them. And then here, the next 3 lines, we also did not make any changes, so we can skip them. And here, we added a base element. So we're going to select this and copy. And in the TypeScript version, we're going to paste that change. And here, we also deleted the title. So in the TypeScript version, we're also going to delete the title. And here, we added a font called Roboto. So we're going to move this change by selecting it and copy. And in here, we'll paste the font. And if we need to fix the formatting, we can select this and press Shift-Tab to remove some indents. And I'll scroll down And for the rest of the code, we did not make any changes. So now we moved all the changes over. I'm going to save this file and close this for now. And then in the copy, we can delete index.html. And next, we don't need to move package.lock.json over because this will be auto-generated when we npm install. So we can just delete this file. And I'll scroll back up. And we'll move over package.json. In this file, we didn't change anything at the top, but we did add some dependencies and dev dependencies. So we're going to move these over. We'll select the dependencies and copy. And then in the TypeScript project, open package.json. And in these dependencies, we'll type comma and paste. And then we'll remove any duplicates. So we'll remove React and React DOM and save. And we'll scroll back up and open package.json. And we'll do the same thing with the dev dependencies. So we'll select all these dependencies and copy. And in the TypeScript project, package.json, in the dev dependencies, at the bottom, we'll type comma and paste. And we'll remove all these duplicates. So I'll remove ESLint, and I'll remove these duplicates, and these duplicates, and these duplicates, and remove this until there are no more duplicates remaining. And now we'll save, and then we're going to run npm install to make sure we successfully install all these packages. In the command line, we'll go to the tab for the TypeScript project, and we'll run npm install. And now we can scroll up and delete package.json. And we'll keep going. For readme.md, we didn't change this file, so we can delete it. And this file, setuptest.js, is new. So we'll move this over to the TypeScript project. And we'll scroll up. And we're going to move over vite.config.js. So in here, we added a bunch of configurations. So in the TypeScript project, we're going to drag vite.config.ts at the bottom. And we're going to move our changes over. So inside the config, we added some stuff for the React config. So we're going to select this React config and copy, and then select this code, remove it, and paste. And we'll keep going. So all of these configs are new. So we can just select this code, and then copy, and inside the TypeScript version, we're going to paste and save. So now we moved all of our changes over to the new project, and we can delete this file. And I'll close this for now. And finally, vitetest.config.js is new. So we can drag it into the project. And now we moved all of our changes over into the TypeScript project, and I can delete this copy. Next, we're going to go into the TypeScript project, and we're going to fix the errors. First, we'll open main.tsx. And in here, instead of importing from app.jsx, the file is now app.tsx. So we're going to update that. Also, we have an error here. So this code tries to get an element from the page using the ID root. However, this element might not exist. So TypeScript gives us an error telling us this value might be null. However, if we check our index.html and scroll down, we have an element here with the ID of root. So we know that this element definitely exists. In main.tsx, to tell TypeScript that this value definitely exists, at the end, we're going to add exclamation and save. So this tells TypeScript that this value definitely exists and it will not be null. And now the error is gone. Next, we'll open app.tsx. And up here, we get some errors when we are trying to import these files. The reason we get these errors is because these files are still .jsx files or JavaScript files. So we could rename all of our files to .tsx, but then TypeScript will start doing type checking in these files, and we may get a bunch of errors. Instead, in our files, we can scroll down to tsconfig.app.json. And inside here, we're going to add a setting, double quotes, allow capital J S, colon, true, and comma, and save. So this setting lets us mix TypeScript and JavaScript files in our project. So now in app.tsx, our TypeScript code can also import from JavaScript files, and it won't cause an error. So the allow.js setting lets us gradually convert a JavaScript project to TypeScript, one file at a time. Now that we fixed the errors, let's run this project again to see if our e-commerce project works with TypeScript. In the command line, make sure you're in e-commerce project TS, and we're going to npm run dev and press enter. And now, if we open this URL in the browser and refresh, and now you can see that our e-commerce project is working with TypeScript. If we try some of the features, like add to cart, you'll see that everything still works. If this does not work for you, you can check the troubleshooting guide in the description. Now let's go back to our code, and let's rename our folders so that we use TypeScript by default. We're going to scroll up, and we're going to rename e-commerce project, right-click, rename to e-commerce project-js for JavaScript. And then we're going to rename e-commerce project-ts to e-commerce project. So now, by default, our project will be using TypeScript. And just to make sure, we're going to go to the command line and stop the Vite server, and we're going to delete all our tabs. So here we'll also Control-C to stop the backend and delete all the tabs. And then we'll reopen the command line using the terminal menu and new terminal. And we're going to restart the backend using cd e-commerce-backend npm run dev and create a new tab. And we'll run the front end, cd e-commerce-project and npm run dev. And in the browser, we'll refresh, and our TypeScript project still works. We'll go to VS Code, and finally, we're going to organize these folders a little bit. So right now, we're no longer using the e-commerce project JavaScript version or the React Basics folder. So let's click outside, and we'll click here to create a new folder, and let's call it old-projects. And then we'll drag the JavaScript version into here, and we'll move React Basics into here. So now our folders are a little bit more organized. So now let's save this into Git. we'll open the Git section. And at the top, we'll use the message convert e-commerce project to TypeScript and commit. Next, we're going to learn an intro to TypeScript with React. First, we'll go into our files, and in the project, we're going to go to source, the utils folder, and we're going to look at money.js. Currently, this is a JavaScript file. That means there is no type checking in this code. So we're going to convert this to TypeScript by right-clicking and rename, and we'll rename it to money.ts or TypeScript. So this converts the file into TypeScript, and now it will enable type checking. And now we will get an error here. So this error says amount sent implicitly has an any type. So what this means is that earlier we learned the feature type inference, which means TypeScript can figure out the type automatically. However, in this situation, TypeScript does not have enough information to figure out the type of amount sent. So we have to set the type manually. To set the type of a parameter, after this parameter, we're going to type colon, space, and then the type of this value. So in this case, amount sent should be a number. So we're going to type number and save. And now that TypeScript knows what type of value this is, the error will go away. And now we successfully converted this file to TypeScript. Let's do another example. We're going to go to the components folder, and we're going to convert header.jsx into TypeScript. So we're going to rename this file to header.tsx. So tsx is just a TypeScript file, but the x means we can write HTML inside this file. So it's just like JSX, except it uses TypeScript. So now this converts the file to TypeScript, and it enables type checking, and we get some errors here. If we look at this error, we get a similar error. Cart implicitly has an any type. So again, this means that TypeScript does not have enough information to figure out the type of cart automatically. So we have to set the type manually. We might try to add the type after cart, like this. However, this is not how we add a type to this code. Because remember, this code is actually a shortcut for this code. This is called the destructuring shortcut. So this whole thing is the parameter. So we need to add the type here, after the parameter. So this code is a shortcut for props, which is an object. To tell TypeScript that this is an object, here we're going to type curly brackets. And then inside here, we can also tell TypeScript what properties are in this object. So in this object, we have a cart property. So in the type, we're also going to add a cart property. And remember that the cart is an array like this. So we're also going to tell TypeScript that this cart is an array using colon and square bracket semicolon. So again, this code tells TypeScript that this value is an object with a property called cart, and the cart is an array. Next, we can also tell TypeScript what is inside this array. In front of the array, we can type curly brackets to tell TypeScript that this is an array of objects. And inside this object, we can also tell TypeScript what properties each object has. So inside our cart array, each object has a product ID. And this product ID is a string. So we can tell that to TypeScript using colon string semicolon. And each object also has a quantity. And this is a number. So we can tell that to TypeScript using colon, number, semicolon. And each object has a delivery option ID, which is a string. So colon, string, semicolon. So using this code, we can tell TypeScript exactly what type of value this is. It's an object with a property called cart, and the cart is an array. And each value in the array has these three properties. So now TypeScript can actually look at the rest of our code and check if each value in the array has a quantity. And if we accidentally misspell quantity here, like this, TypeScript can use this type here to check if we made a mistake. So this helps us avoid a lot of mistakes when we're coding. So let's add that back and save. Next, we're going to organize this code a little bit. So putting a complex type directly in the code like this is a little hard to read. So we can actually take this type and then save it separately. Above this component, we can use type space and then give this a name. So here, this value is the props for the header component. So we'll name this header props. And we'll type equal, and we're going to move this type up here. So we'll select this type and cut, and then in here, we're going to paste. So this is called a type alias, and it works just like a variable, but for types. So we can save a type in here, and then we can use this type later in our code. For example, down here, we can just use this type, header props, and it will substitute this type into our code, just like a variable. And now our code is much cleaner. So that's an intro to how to use TypeScript with React. We basically add types to React features like props. So now let's save, and we'll save these changes into Git. In the Git section, at the top, we'll use the message convert money utils and header to TypeScript and commit. Finally, we're going to learn how to use AI, or artificial intelligence, with React. After we learn React, we can use AI to help us write React code faster. The easiest way to get started with AI is to use GitHub Copilot, which is built into VS Code. Before we begin, AI tools are changing very quickly. If something in this section is not working, you can check the troubleshooting guide in the description. To set up GitHub Copilot, we're going to install the GitHub Copilot extension. So in the extension section, we need to make sure we have the GitHub Copilot extension installed. If it's not installed, we can search up here for GitHub Copilot and install this extension. Once we have that installed, we're going to click this Copilot icon up here. And we'll need to log in to our GitHub account. So we'll click Sign In, and then we need to log in to GitHub. If you don't have a GitHub account, you can create one by clicking here or going to github.com. So I'm going to log into my GitHub account. And then I'll click Continue. And I'll click here to go back to VS Code. Once we finish the setup, we can start using some features of AI. The first feature is autocomplete. So let's say that we're in the header, and we'll close this window for now. And let's scroll down to the HTML, and we're going to go to the right section. Let's say that inside the header, we want to add a link to a login page. So here, we can just start typing in this code, and the AI will give us some autocomplete suggestions. To accept these suggestions, we can press Tab. So this creates a new link and some text. And I'll press Enter, and it gives another suggestion. So I press Tab, and this creates the closing tag for the link. So you notice that the autocomplete is very smart because the AI can read and understand the rest of our code. And it can suggest code that follows the same patterns as the rest of our code. For example, here it creates a link element and it gave it a class name that is similar to the other class names. However, when using AI, we may need to go in and modify things to make sure we get exactly what we want. So here, the AI created a link to the home page, but what we actually want is a link to a login page. So I can click here and modify the URL path to /login. And I can also change the text to login. And I'll change this to login. And I don't really have an icon for the login page, so we can delete it. And I'll change this to login. So using AI, I'm able to write this code a lot faster. Another feature of AI is we can give the AI instructions. For example, let's remove this code for now. And we can click this Copilot icon, and it will open this chat window. And inside here, we can just tell the AI what we want to do. For example, in here, we can say in the header, add a link to the login page. And make sure in this dropdown, you have agent or edit selected. And we'll press enter. And the AI will make edits to our code. So here, you can see that it added a login link like before. So we can press keep to keep these changes or undo if we don't like these changes. So this looks good to me. So I'm going to press keep. And again, I'll go in here and modify it a bit. So here, it added the login link after the orders link, but I want to put this before the orders. So I can just select this code and cut, and at the top, paste that code. So as you can see, by using AI, we can write React code faster. But you'll notice that we still need to understand the code to check if it's what we want and to modify the code if we need to. So it's important to learn how to code first, and then we can use AI to help us code faster. So now I'll go into the Git section, and I'm actually going to undo these changes because this was just an example. And that's the end of this lesson. In this lesson, we learned some of the updates in the new version of React. We learned how to set up the React compiler to automatically optimize our React code. We set up a new TypeScript React project using Create Vite. We did an intro to TypeScript and learned basic features like type checking and type inference. We converted our e-commerce project to TypeScript. We learned how to use TypeScript with React. And we learned how to use AI with React to help us write code faster. Here are some exercises to help you practice what we learned in this lesson. Good job on finishing this React tutorial. If you want to continue learning with me, you can check out the premium version of this course where I will be adding extra lessons and projects in the future. Currently, the premium version has 11 lessons, but I'll be adding more lessons in the future. You can also check out the membership for extra content on AI and backend. As the next step after learning React, I recommend moving to the backend and learning the command line and Node.js. I'll be putting my work in progress on these technologies inside the membership first, so be on the lookout for that. Thanks so much for watching and taking this course with me, and I'll see you in the next one.